a vectable garden with two gates. The garden has a length of 35 feet and 17 feet respectively. It has a length and a width of 35 feet and 17 feet respectively. Simply meaning the length is 35 feet and the width is 17 feet. In that order, respectively means in that order. All right. Note the width of the small gate. Okay, when you look at the garden, this is it. Those dots are poles that are going, this line they represent the round one, represent distance covering sorry, not covering, total distance around the vegetable garden. Total distance around the vegetable garden. The total distance, you can see length garden. The total distance, you can see length around the vegetable garden. Vegetable garden. State whether the dimensions of the garden are in metric or imperial. Remember, metric is where we look at kilometers, meter, centimeter, millimeter. Now, imperial, we look at miles. Imperial, we look at miles. We have yards. We have feet. We have inches. So we go and we check on the garden, the dimensions. They are in feet. So your answer is what? The measurements here are imperial. Measurements there are imperial. Another thing that I've forgotten about the perimeter. Perimeter, it's when you start from here, you come there, you come there, you come here, again you go. So the distance that you move from here, you go like that, you add. That's how we get the perimeter. When you move around a given shape of a given area. Around, which means outside. Meaning it's the same as the space occupied by the fence. or boundary. All right, a boundary around a given shape or area. Determine the ratio of the width of the smaller gate to the large gate. Remember, they gave us those measurements. They're here. But what I wanted you to know, first and foremost, know its ratio of the smaller gate and the larger gate. The smaller gate, what's the width? We come back to the scenario here. We have it at 0.9 meters, and the large gate is what? 1.8. In that order, please. 0.9 is to 1.8. Simplify it, become 1:2. 1:2. Calculate the perimeter of the rectangular vegetable garden in feet. You may use the formula below. Now, someone might ask us, shall we count the gate? Yes. Why? We are looking at the vegetable. We are not looking at the fencing, but we are looking at the perimeter of the garden. They are saying it's supposed to be in feet. Remember, length is 35 feet. And the width is the 17 feet. Substitute. So we shall say perimeter equals to 2 into 35 plus 17. We are looking at perimeter. Perimeter needs us to have length. It's already given to us at 35. These are feet. Then we also need to have the width, which is 17 feet. So we need to substitute, and we shall say perimeter equals to 2 into length plus width. I'm using this other part here, which is 2 into 35 plus 17. See that? So we go straight forward, and you see we have the answer as 104. These are feet. So they are telling us, hence convert the perimeter of the garden to meters. So here we already have it as they are telling, if you only have 1 foot, you have an equivalence of 0.3048 meters. So for us, we have 104 feet. What would it be? We cross multiply. So the answer is to be telling us it has to be 3,16992. These are meters. These are the gates. So what we're going to do, total perimeter of the fence. So we already got the answer there up there, which way we said it was 35. Added the 17. We got the answer as what? These were feet. We changed them to meters. And the answer we got it at 6992. Here, we shall subtract the length, the width of the small gate, which is 0.9. And we shall subtract this width of the smaller gate, which is that much. So remain with 28,9992. So these are the meters that we need. So we shall divide this by 10 because it's sold in 10 meters. So we divide that by 10. You see, you find yourself that you made with 8,9992. But remember, these are rolls, so you cannot buy them in half. So the person will buy 3 10-meter rolls. 3 of them, but the third one won't be fully used, but part of it will be used. They're asking you calculate the total cost of the machine wire face. That's so already we've seen that we need 3. 3 times 1,599. The answer that you get, equal to that much. Answer you get to equal to that much. Give one valid reason for putting a fence around the vegetable. And then the valid reason is known for the animals not to destroy the garden. If you have animals at home, you protect them. You protect the vegetable garden from those animals. So by putting a fence, not to destroy the garden, the livestock, not to destroy the garden. Then the other one, what would it be? Also to be neat, protect your garden from intruders. Three 3.2, when you look at 3.2, almost the same part that we're looking at. And here we have this diagram here. Now this is from Mr. Malin intends to increase the area of his garden to plant more vegetables. Shows the dimensions of the existing garden and the alternations to the new garden. You understand? The existing is this blue one. Then these dotted ones are the extensions, which becomes the new garden. The garden has a circular garden bed with a diameter of 1.5 meters. Okay. Determine Mr. Malin's new length of the garden. Now, you're taking the old plus the new one. So it's 11 plus 2. So the new length equals to the old plus the new. So we added that up. Take the area of the new garden in square meters. So the width is 6 meters and the new garden is 13. So let's go there and say our length is 13. The width is 6. And the answer becomes 78. The answer becomes 78. Don't forget these are meters what? Squared. You show the units because even there they said in meters squared. So please, you don't forget the units. These are just meters, they're not squared because just we are adding. Here it's a square because we've multiplied 2 times. We've multiplied the meter from here and another meter here. So we multiply the 2, you get meter squared. Here we're just adding. You don't get anything. It remains the way it is. We go to 3.2.3. Martin stated that the percentage increase in the area of the new garden is 40%. So how are we going to get this? Number one, we shall need, we need to know, because to get the percentage change, you need to get the new area. Allow me write it like this. Minus the old area. Everything divided by the old area times 100. Why? I'm looking for the percentage. Anyway, I have the new area. What about the old one? So I need to look for the old area, which will become L times what? B. Let's go back to the diagram. What's my old area? It's 11 by 5. So I'll come here, multiply 11 as length, 5 as width. And the answer becomes 55 meters what? Squared. So I have the old area. I'm good to go. I'm going to substitute. I'll say my new minus old divided by old times what? 100. The new is 78 minus 55, which is the old. I divide by 55 and multiply by 100. What answer do I end up having? 70 minus 23 divided by 55 times 100. So the answer here, you have it as 41.82%. So if you round it to, it's what they are saying is that the percentage increase. No, the answer is what? Invalid. Why? This is not 40%. And he said it's 40, and it's above 45, it's 40%. Then it will be valid. Why it's above? And he said it's less, it will be false. Incorrect. All right, let's look at question number 3.2.4. Show by calculations that the area of the circular garden bed is 1,767375 meters what? Squared. Remember, we are looking at the circular garden. And indeed, they have given us the circle here. They have given us the area. The area needs the radius. And in the scenario, remember, they told us that it has the diameter. So how to get the radius? Radius equals to diameter divided by 2. They told us the diameter was 1,2. The answer becomes 0. You see, the diameter is 1,5. Sorry, not 2. So we do that. 1, divided by 2. We have the answer 0,7. Now our radius is 0,7. So we come substitute in the formula. Squared. So 3,142 times 0,52 square equals to 1,767375. 3 marks. Did you look for the radius? Yes. Did you substitute correctly? Yes. Yes. Answer here is Z. All right. Name two time formats used to display time on the clocks. Now, as I told you, there are two of them. You either call it analog, which is the same as 12-hour system, or you can call it digital, which is the same as 24-hour what? System. All right. But you have to remember, in analog, this is where we have AM and PM. Here, we have nothing like that. However, when it's past afternoon, the hour you add on what? 12. By the morning, same until past afternoon. You made the same until noon. Then after that, you start adding on 12, 12, 12, 12. You get the answer to be displayed in digital. All right, write down in words the time displayed on clock B. Let's go to clock B. When you look at clock B, it's a digital already together, but I want to write it in words. I mean in words, not in numbers. Let me write it down here for you to see what they're trying to say. This one, write it in words, is supposed to be a quarter to, a quarter to 1 p.m. Oh, you can say a quarter to 1. We didn't know whether it was morning or it's in digital form. Yeah, it's a quarter to 1, as in 1 p.m. Or you can say a quarter to 13 hours. All right, because from here we are expecting 13 hours. All right, write down the number of clocks that clearly indicate a time in the afternoon. Write down the number of clocks that clearly indicate a time in afternoon. Let's come here and you see clearly. So this is one of them. B, it's afternoon. Because if it was, because it's digital, in digital midnight, it would be 00:45. You see that? But now this one's clearly afternoon. Why? It's because it's in digital format. It was not supposed to be like this one. Also, it's another one. Clearly afternoon. Together. For the analog, we cannot use because we don't know where it is or what it is. Are they put AM, PM, then we would tell. But we are only looking at digital. So it's only B and E. Write down the number of clocks that clearly indicate a time in clearly. Take note of this, clearly. So we don't want to guess. If you use analog, you'll be guessing. So we said they said write down the number of clocks. So how many are they? There are only 2. In brackets, we said B and E. All right, please, you may pause and refer to the annexure. All right, let's continue and we see what's happening. Convert 16 hours, 45 minutes to minutes. Convert 16 hours and 45 minutes to minutes. In other words, these are already hours. These are minutes. We don't need to change them. Why? Our main aim is to have minutes. So remember, these are 16 hours. We need them to become minutes. Yet 1 hour has 60 minutes. Simply meaning, get the 16, multiply by 60, get the 16, multiply by 60. We are fighting to see that they become minutes. So 16 times 60, you get 960 minutes plus 45. So all in all, we have the total number of minutes as 1005 minutes. 1005 minutes. Hours, they became minutes. Minutes, they're minutes. You can't change minutes to minutes. So you add everything together. We are continuing. Let's see that we go through this. All right. In paper 2, we shall be expecting measurements. Actually, you're looking at measurements and conversions. All right. And assembling of objects like we see here. Illustrated below are steps and some instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners, brackets, screws and bolts, washers and nuts. These are 32. Okay, there are 32 pieces in the packet of fasteners. Each bolt is secured by a nut and a washer. So Anyway, it's fine. We should not overthink about it, but you understand. One bolt. The bolt is that nail that. So one bolt, it will have a washer. That small, there's a small disc-like material. Then with the at the end, you put the nut together. So one bolt, this is a full set now. One bolt should have one washer and a nut. All right, for screws, you know the screws, you just screw and it fastens the wood. Go straight forward. All right, here we go. They are saying part A, it says, so the step one says attach the seat using bolts, which is B, nuts E, and washer D to the front, so to the two front legs. Attach the long, which is A. Then we go to step number 2, which says attach the arms to the two front legs using the bolt C, E, and D. So here we go. We have attach the back of the seat and the arms using the screws, which is A. Together. Then step number 4, it says short brush. Okay. Here we go. Use C. Determine the number of type C bolts used to assemble the deck chair. We are looking at C. The number of bolts. Determine the number of bolts. Okay, how are we going to determine them? Remember, they told us there are 32 pieces in the packet for fasteners, and each, remember, they said these pieces of a chair are joined together and using fasteners, of which fasteners include screws, bolts, washers, and nuts. And they're telling us that in only one packet we have 32 pieces. So let's come down here. When we look at this, when we look at this bolt C, they are missing. Numbers are missing here. So in other words, we need to know when I add my 8 screws plus my 6 bolts plus my type C bolts, which are not there, I will leave it as C, plus my D, which is 8 washers, plus E, which are 8 nuts. I should get the answer as 32. Where am I getting 32 from? From the scenario. A pack consists of 32 pieces. All right, when we add this very well, we shall end up saying that the answer that we have is 14 plus 8 is 22. 22 plus 8, you get 30, which is this means this simply means we have got 30 bolts plus C should give us what? Should give us 32. All right. So having done that, but when you add 30 plus C, what you get 32. So meaning our C is supposed to be 2. Our C is supposed to be 32. All right, state the number of nuts left over after step 1 is complete. Step 1, let me see. Step 1, what does it need? Step number 1 needs attach the seat using bolt B, bolt B, nut E, and washer D to the 2 legs. So here we are. Let me see. And the A, but they're saying here, the question asks us, state the number of nuts left after step 1. Step 1, how many nuts does it need? You understand? We have the type E nuts. But how many of them? We shall have, let me see here, we have E again. We shall have 6 nuts. 6 nuts, because here we have, let me see. Attach the stitches. They never told us how many nuts are inside here, but anyway, we shall take it to be here. You take E, 1 E. Also this other side you take E. So of the 8, you've taken off 2, because of these 8 nuts, you've taken off 2. So how many do you remain with? 6. 6 what? Nuts. Name the last piece required to complete the assembly of the chair. It was already named here. The last piece to it's this A. This part here. The short brass. So short brass. All right. 1.1.3. We have a map here that we need to look at and analyze. All right. They're telling identify the type of scale used. The scale is this one, which is here. Together. This one, whoever said a bar graph, a bar scale, sorry. Whoever says a bar scale, my friend, you're right. No any other. Guys, please refrain from guessing. Find someone saying a map scale because it's on a map. No, it's called a bar scale. Also, someone who says a line scale to be fine, but the right answer is supposed to be a bar scale. Name the province that lies east of Northwest. Remember, the map, what is it about? Or what is it for? It's for the Northwest. Yes, so definitely, Northwest cannot be east of Northwest. You understand? So they are saying, name the province that lies east of Northwest. East of Northwest. So first and foremost, look for a compass. If it has no compass, we take it by the compasses here. Simply meaning, it's like this now. The compass. This is the compass now. So we have north, south. This side becomes what? East, and this is what? West. So we come here. So we are supposed to look on this side here. East of north, west. So here I say Gauteng. This is Gauteng, but then this is east. What about north? Because if this is northwest, and we are looking for that lies. They said the province that lies east of northwest province. East. So we shall say it's what? Gauteng. It's directly there. It's Gauteng. Gauteng lies east of northwest. All right. Identify the national roads that passes through Freiburg. First and foremost, identify the place. This is it. This is Freiburg. So we look for national roads. We have N14. It comes here, it continues as N14. Here we have N17. N17, which is this, N14. It's around what? Freiburg. All right, those are the steps that we see. So they pass through. So they said, identify the nationals that pass through Freiburg. So we say N14 and N17. 17, as we saw it on the map. All right, I'll write down the number of destination towns / cities shown on the map. There's a number of destination towns / cities shown on the map. Now, if you don't know that, most questions they have a key together. So they're saying write down the number. They didn't say mention, but they said write down the number of towns / cities. So what we're going to do, whatever word we find in this box like this, you just know it's a destination town or city. So here I have my friend 1, the other one's called 2. We have 3. Come down here, count that 4. We have 5, 6. We have 7. All right, someone might think of Pretoria. No, yes, it's there, we see it, but it's not in that box. Together? Another thing, someone might think of the N4s and the N. No, these are roads. They are not destination what? Towns. So we have 7 destination towns / cities. 7 destination towns or cities. That's it. Okay, here we go. Unfortunately or fortunately, we are not using any ruler. But if they say measure in millimeters, my friend, here, this is when you pick your ruler. Pick your ruler. When you pick your ruler, please you measure the distance, as they have told you. Now, in brackets, I've said, as the crow flies. So in simple terms, here, they don't want you to use the string or the thread. Here, use a ruler, and it will be a straight what? A straight line from one point to another. Now here they're saying, as the crow flies from Blue Mouth to Leichenberg. Together. So you come here, identify the towns. We are here. Together. Then we are going to Leichenberg, which is this one here. The place is here. Ne? So put your ruler here up to here. Measure the distance that you get. Measure the distance that you get. Measure the distance that you get. So now what you're going to do, what you do now, it's going to just show you here something small. All right, you get your ruler. Then you measure from this distance here in a ruler. Please, with a ruler, sorry. You measure it from this place to this place. So let's imagine you have approximately, they said measure in millimeters. So you write it, approximately you have 12 millimeters. Yeah? So you come here down. No, this is too much. It's not probably, let's say you have 50. If you've got here 50 millimeters, you come down here and you measure it. Just write and you say 50 millimeters. You use your ruler there, please. All right. Let's look at question number 2. Question number 2. Question number 2 talks of the annexure. Get it, please. What we see, it's what they want us to look at. So we are looking at question number 2.1, annexure A, which is 2.1, All right, it talks about seating plan, I believe, and as you show it, as you see it, Annexure A shows a restaurant seating plan for customers. Use the information on Annexure A, answer the following questions. Give one possible reason why this restaurant has so many windows. One possible reason. This is simple. Number one, to have fresh air. You understand? We need fresh air, air circulation, air flow. Number two, to have enough what? Enough natural light. You understand? And if you have enough natural light, guess what happens? You don't need to switch on the lights. In the end, you cut on electricity. All right. Someone might have other reasons, like for easy fire fire for example, in case of fire incidences, it's easy for customers to exit instead of them using one small exit. Others can jump over the windows and an easy way of escaping. All right, calculate the maximum number of chairs available for customers. Let's go to our next chair. The next chair is here, and numbers available for customers. Please take note. How many tables have four? We have one. We have 1, 2, 3, 4, 5, 6, 7. So this, remember, we're looking for the maximum number of chairs. So only these ones that I've ticked now, they are 7 tables, but each has 4 chairs. So those are 28 chairs. Keep them aside, please. Let's continue. How many tables have 1, 1? So we have 1, 2, 3, 4, 5, 6. So these are 6 what? Plus 6. We are going to add on. How many tables have 2? 2. It's only 1. So plus 2. Plus. How many tables have 3? We have 1, 2, 3, 4, 5. So it's 5 tables with 3 chairs. How many chairs are they altogether? 15. So what? 15 chairs. Plus, what's missing here? What haven't you ticked so far? We talked of chairs. We cannot count couch. All right? We're only looking at chairs. So here, the table number 18 has how many chairs? It has 6. Together. So table number 18 is the last one. All right? Someone might have seen the number of tables, 21. You get 21 and say, there are 21 chairs. No, we are counting chairs that are available, maximum number of chairs. So you've seen it's 28 plus 6. I think 28 plus 6 plus 2. Six plus 2 plus 15 plus 16 plus 6, sorry. Plus 2 plus 15 plus 2 plus 6. No, there's none of that. It's just like this. So 28 plus 2, 30. 36 plus, because I say 20, then here only it's 36. 36 plus 15 plus 6, you get 57. So we have 57 seats available for customers. 57 chairs, by the way. Determine the number of seats directly facing the wall on the south side. Let's go back to our next chart. So if you hear south side, so first and foremost, look for the campus. Together, the campus is not there, but they have given you here the main entrance doors are on the south side of the building. So definitely you have to look for the main entrance. So if the main entrance is here, so you're looking for chairs that are facing the south. Here we shall count them critically, or let's go and take note of the question. They are saying, name the number of seats that directly face the wall, the south side, directly face. Here we shall have, I think, two answers. Directly, so we have 1, 2, 3, 4, 5, 6. Yes, 6 what? Chairs. 6 would be okay. 6 seats. Or you say 6 plus. I'm going to show you something small here. This is facing the south hall. This is facing. Come to this one here. Come to this one here. Another one. Look at this one. What about this one? You see that? So you have 1, 2, 3, 4, 5, 6, 7. They are all facing the south. The south directly. Not because these ones can, but this is diagonal. We can't count these, but these ones are directly facing. So you can say 1, 2, 1, 2, 3, 4, 5, 6, 7. So I believe also that one who says 13 chairs, it's to be fine because we are adding all those 7. All right, let's give one reason why the restaurant has couches at the entrance. Definitely now the couches will be used by those ones who are waiting for takeaways, I believe. You see that? Not for customers who are waiting for their orders to stand in the queue. You know, it confuses. For example, if you go to KFC and you find people waiting to collect, there will be also lining, as well as those ones waiting to order. So it confuses a little bit. But if someone is waiting for an order, let them have a seat. Then you know what? I'm left with these ones to serve. So the couch are for those ones who are waiting to take their orders. Give one reason why a restaurant has couches. Give a reason why a restaurant has couches. So here we go, 2.1.5. A person at the table 18 leaves her seat and walks towards her friend at table 4. She uses arrows. She uses the arrow path shown on the seating plan. Use the compass direction to describe. Use the compass direction to describe the path from table 18 to table 4. Use the now when you hear compass direction, what comes in your head? You need to mention north, you need to mention east, you need to mention west, you need to mention south. At the end, you're looking for news. Are together? So let's go there and we see table 18 is heading to table 18 is heading to table 4. Table 18 is heading to table 4. Let's go and check on their next year. And next year, and next year. Let's look at their next year. All right, the person is in table 18 here. But okay, the person is going to use, they said use the arrow direction. At the end, they're also using the compass. So the compass, remember, this is north. So this is what? South. Why am I saying that? Because they told me the main entrance is found at the south of the building. So the person, table 18, they will move in the southern direction, because they need to move like this. They're saying describe. They move southern direction. You move in the southern direction, or you move south towards table 7, pass table 7, then turn east. Turn east. Turn east. Having if you turn east, the third table on your left, that will be the person, because this is table 4. Person is coming from table 18. So south and east, right? But if at all they are not said, use the compass direction, this would be the person stands up, he moves towards table 7, which is he moves towards table 7 here, which direction is that? We can't take straight forward, because if a person was seated here, he definitely has to leave the table, come onto this line, then he moves down. As he's moving down now, this is his right and this is his left. For you, this is your left and this is your right. But for him, his left would be here, his right would. So he will come here. So he will turn left after table 7. Then the person will be on the right hand side after turning. All right, let's continue. We look at question number. Norm claims that there are less than 21 tables for customers in this restaurant. State a reason why, whether her claim is valid. All right, let's go and we say a mixture. Let's see if they are less than 21. Indeed, they are less than. Let me see. I'm going to count them. So we have 1, 2, 3, 4, 5, 6. Yes, these are 6 tables. 7, 8, 9, 10. Yes, 10 tables. 11, 12. Yeah, 13 is missing. 13 is missing. 14, 15, 16. 16. 17 is there, 18 is there, 19, 20, 21. Yes, there are 20. 13 is missing. There's no 13. Together? So we say there are 20 tables because the 13th table is not there. The 13th table, or table 13, is missing. Table 13 is missing. State the reason whether her claim is valid. It's valid. State whether the reason why. State whether that statement is valid. Yes, there are 20 tables. The 13th table is what? Missing. It's not there. All right, let's look at the next chapter B. Look at the next chapter B. Next chapter B, probably when I look at it here, I see a tree diagram. A tree diagram. Why do I say tree diagram? This is probability. A tree diagram because I see options. 1 protein, chicken. You take one of the, all of these are proteins, but you take only one. Then one side order, vegetables or salads. That's you pick one. Dessert, it's either ice cream or pudding. You understand? So that's why I just look at it and I see that it is what? This is This is probability. And they're asking which type of diagram is illustrated on annexure B. Let's go to annexure B and we see. Annexure B, here we go. All right, this is annexure B, and as I guessed, it's probability. The kind of diagram that we see here, it's called a tree diagram. This is a tree diagram. These are the branches. These lines that you see, those are the branches. Together? By the way, we have no leaves and we have no stems, but these are the branches. We don't have roots. I think the roots would be these numbers that we see here. Anyway, look at this. As you see the table itself, as you see the diagram, the tree diagram. This represents the first chance, the second chance. Together, this is the second first chance. Sorry, it's this one here, because here we're supposed to also have a tree, as in it has to be coming. So this one is the first leg. This is the first leg. So this is the first leg whereby they had to come together. So here they need to come together like that. So that's how it is. So in case one is missing, for example, this one here, you will have to work backwards. For example, this, let me see, this is 2.2, 2.2a. They are missing. Anyway, we see that this combination was got from here. They began with a certain letter, which is F. So here it's supposed to have F. F, V, I. F, V, I. Let's come here. F, V, M. F, V, M. So F is supposed to be here. Let's guess. Someone give us the answer here. The answer here is supposed to be, now look at all these combinations under this. They all start with C. Definitely your answer is supposed to start with C, which is this one here. But it's at the last place here. So it's C, goes with S, and it ends with M. So C, S, M. That's supposed to be the answer. This is the tree diagram that we are looking at. That's how we get the combinations. Last example, or that solution that I'm giving. Let me see, we have, for example, how did they get this? They took the B, wonderful. They took the V, wonderful. And they ended with M. So the branch went like that. Then it collapsed like that. Everything. That's how we answer. Please never leave such a question unanswered. All right. We consider them to be free marks. We continue the other question. You see, what other question are they saying? We've already completed this. They're saying, name the type of diagram illustrated in annexure B. I've already told you it's called the tree. The tree is called the tree diagram. Write down the missing outcomes. We've already seen them from the annexure, which were A is CSM, A, CSM, and the B was F, fish. Say the number of combinations with beef as proteins. These ones are 4. There are 4 combinations. Let's go back to the next one. You see beef, which is B. It has split here, and look at where do you see B only? So you have 1, 2, 3, 4. So these are the 4. These are the 4 combinations that we have. The other question has to be, or it was, determine as a percentage the probability of randomly selecting a male with folding as desert. Now, what we're going to do, this is the sample. So probability will always equal to sample over the population. Sample over the population. Now, what's the population? The total outcome, the chances. Together? Then a sample, part of the population. Many of you have gone to supermarkets and you've seen that they're giving you, they will tell you that these are samples, simply meaning it's not a full pack, it's not a full package. They give you something small. So a sample is part of the population. All right, let's go there and we see. The sample you're looking for, it's the M. Together? But out of what? How many outcomes do we have? Here we have 4 of them. Here we have 4 outcomes. Here we have 4. Also here we have 4 out. I'm counting these outcomes here. Are they? Then having counted these outcomes, so all in all they are 12. So population, my population is 12. Of these 12 chances, how many combinations have M? How many combinations have M? I'll start with this one. This one has M1. This one has M2. This has M3. This has M4. This has M5. This has M6. So out of the 12, we have 6 chances that someone of picking someone who has taken OD. So we shall say it's 6 out of 12. They say determine as a percentage. So what do? We multiply by 100. But I'm here seeing 6 over 12 times 100. Your answer, it will become 50%. Why did I multiply by 100? They asked me to determine probability as a percentage. And I went ahead, I used the probability method, which is sample over population. But because they need a percentage, I multiply by 100. Out of my 12 chances, I have 6 which I'm sure of. Over 12 that are all the ones. And I multiply by 100, I end up having 50%. 2.3. Below is a simple route map of Los Angeles Marathon, LM, in the United States of America. LM, it's 26,2 miles. All right. By the way, the moment I heard of America, guess what came in my, remember we have two systems of measurements, ne? We have the metric and we have what we call the Imperial. The metric, it's what you use in South Africa, kilometer, meter. We go to centimeter and millimeters. Whereas Imperial will start looking at miles. After miles, we look at yards. After yards, we look at what we call feet. And we shall look at inches. This is Imperial. Together, let's keep that in our heads. For metric, they'll always ask you to provide the values. But for Imperial, they will always give you the conversion factor. Anyway, keep this in your head, 26,2 miles. Okay, here we go. They say explain the meaning of the route map. This is straightforward as you look at it. The route map only shows, or it shows the way people who are running will follow. You understand? Route. Which route are you going to take? Together? Remember, this is a marathon whereby people run in big numbers over a long distance. Together? Marathon, we also have what we call the cross country. I think the cross country is in the countryside, right? Whereas a marathon, even marathons, I also can, no, cross country is a longer one. Eh? Anyway, map not on scale, simply meaning the measurements are not perfect that much. All right. Describe what's meant by the map not on scale. Together? In simple terms, it's not actual. I understand? The measurements are not actual. It's not on scale. Runners in L marathon have passed the underneath a bridge at a certain point during the marathon. Explain how this is indicated on the map route with no route line. What do I mean? Take note here. There's nothing there. Even here, so simply means they are passing under the bridge. Even here. You understand? Here, they pass under. That's why the route is not indicated. As you here, you see it's clear. But here, it's under. That's how it's indicated. Come here, it's under. Come here, it's under. Also here, it's under. That's how we know that this guy is passed under the. Then this one here would be like a subway. Or a subway, what do you call it? A tunnel. Or lanes. Anyway, let's go and see. Write down the number of times that runners who completed the marathon will pass underneath a bridge. So as I was looking at, I said, how many times? So let's count this as 1. We come to this, we call it 2. Come to this one here, 3. And this one we have it as 4. Any other part where the marathoners not, it's not clear. Probably 5 is something here because this is a start. This is an arrow. There's nothing there. So we go on and you see 5. There's no any other place. All right, this is 5. 5 times. Write down the general direction in which runners will face when they start in Flower Street. Now, when we look at general direction, please take note, general direction, you are not describing any route. General direction, what has to come in your head, it's the compass direction. Some people call it compass. Together? The compass direction, the north, east, west, and the south. That's what we are looking at. So let's go there and we see, they said, write down the general direction in which runners will face when they start running. Now, before you give the general direction, you have to look for the compass. Now, here the compass points at this side. Look at the end. So simply meaning up there. So this side is what? East. This side is west. South. On top here, it's what? North. Together. So where are they facing? You come here. Try to draw the compass and look at where they are facing. South, west. South, west. Avoid writing shortcuts, but you should write it in full. All right. Question number 3. Here we go. These are measurements. Look at measurements. We look at area, perimeter, volume, surface area. Okay, that's wasting a lot of time. Let's look at this. Let's analyze actually the box and we see. Every learner in a technology class is expected to have pre-stick and pretty glue sticks. The pretty is packed in a rectangular box, sleeve, and the pretty is in a cylindrical container. So here we go. Rectangular shape. Here we are looking at it. So we have 2 shapes here. 1, rectangular. 2, cylindrical. All right. The dimensions of the rectangular face of the pretty sleeve are, and the cylindrical pretty containers are given below. All right. Pre-stick and pretty glue stick. Together. This is called a glue stick. So people call it pretty. All right, and we go on. Okay. We have definitely for a rectangle, you expect to have length, which is L, width, which is W. Most cases, we also need height. If it's a 3D. Together. Then a cylindrical, we only need the diameter and the height. This is already 3D. There's nothing much that you need to do. All right, there we go. It's calculate the perimeter of the front of the pre-stick. Number one, pre-stick sleeve. So it's this one here. So the perimeter. So simply meaning, what's perimeter? Perimeter is the total distance around a given shape. And they've given the formula. Please, once they've given the formula and you indeed know that's the right formula, just continue, substitute in it. So we shall start with a 2 times, open brackets, length, 239, plus width, which is what? 89. Make sure that all of them are in the same units. So they are all in the same units. I need to go ahead. So having done that, your final answer becomes, don't forget the units, 656 millimeters. Millimeters. Okay, here we go. They tell us to calculate in centimeters. Take note of that. Calculate in centimeters the height of the opening / the closing part of the pretty container. We come and we see it here and we see, look at that. Look at that. This has parts together. Oh, the cap, yeah. The cover. The height of the opening / the closing part of. So it's the bottom part, né? This one, which is dark here. So we need to know. Okay, they're saying calculating the height. Oh, okay, it's so simple. So what is going to be? Look at this. So simply meaning, when from here up to there, let me call it O. No, Q. Let me call it Q. Because I don't know this, I'm calling it Q because I don't know it. Ne? From there up to there, it's Q. So when I add my Q plus my 7 plus my 2,5 centimeters, I should end up having 114 millimeters. But look at this. These are centimeters. Also, this has to be in centimeters. But these are millimeters. What you're going to do, you're going to change the millimeters to centimeters. So I need to change my 114 millimeters. I need to change it to centimeters. How do you change millimeters to centimeters? I will need to divide by 10. I'll need to divide by 10. So here I end up having 11,4 centimeters. I've changed this, but it's not the end. So we are saying when I get my unknown number plus my 7 plus my 2,5, they should give me 11,14. All right. So here when I add this, I end up having my Q plus 9,5 equals to 11,4. But I'm looking for the Q. Which number do I add to 9,5? I get 11,4. So my Q now become 11,4 minus 9,5. 11,4 minus 9,5. I end up having my answer as 1,9. We said we shall take the total height the total height has to change to centimeters because they need my answer to be in centimeters. The total height, which is 114, we shall divide it by 10, get 1,4. So when we add these other areas, they should give us this. When I add my unknown, add plus 7 plus the 2,5, I should get 11,4. Simply meaning this has to be 7 plus 2,5 plus the unknown. When I add these two, I end up having 9,5. So I will say 11,4 minus 9,5 equals to Q. Equals to, please take note of that, centimeters. The actual height of the glue in Pret container is 8.5 centimeters, and the volume of the glue rounded to 30 decimal place is this much centimeters cubed. Show by calculation that the volume of the glue was calculated if the diameter of the glue is 28 millimeters. The actual height of the glue so the glue inside the container is 8.5 centimeters, and the volume of the glue rounded to 3 decimal places, it's this much. So we need to show that the diameter is this much. But look at the formula they used. You understand? But in your head, because you're determining the diameter, you know very well that diameter is got from you getting the radius and multiplying it by 2. Together. So you're going to use this formula, you're going to use these values here, and the volume and the height of the glue and the formula to get the radius together. So this will be my volume, yes, which is 52,346 equals to 3,142. Do we know the radius? No, but allow me leave it as r squared times, do you know the height? They told us it's 8,5. So we multiply the normal numbers and leave the r squared alone, which is 3,142 times 8,5. You get 26,707. Please, I will leave the number the way it is. I won't round off. Let me do it from here. This is part B. Volume equals to pi r squared h. Remember, they've given us the volume already. The volume was given to us as 52,346. So 52,346 equals, when you multiply the pi and this number here with the height, and having 26,70 times the r squared, because the r is missing. So what do? I need to divide through by, there's a comma here. I need to divide through by 26,77 on both sides. On both sides, so it becomes 5,346 divided by 20. So when I do that, this will die with that. So I remain with my r squared equals to 1,96. So what do? I need to look for the radius, which become the square root of this, square root of my answer. Yes, indeed, I remain with r equals to 1,14. But remember, we are not interested in r, but r will help us get the diameter. What do? Multiply by 2 and times 2. So I end up having, these are centimeters. The proving is in millimeters. I need to multiply by 10. Indeed, I've done it. So this was the answer. This is part A. Part A. Looking for the diameter. What I would advise you to do, let's look at this. Volume of a cylinder will always be pi r what? Squared. So this we can put it in the triangle like this. Volume equals to pi r squared h. So if I'm looking for, definitely pi is a constant number, there's nothing much there. So if I'm looking for h, height, if I'm looking for height, it will be height, yes. What am I remaining with? I'm remaining with volume divided by pi r squared. So simply meaning if I'm looking for height only, height, what am I? I'm remaining with this. So which will be radius squared equals to volume pi r h. But this is squared. So what do we do? Whenever it's squared, we need to apply square root. So we need to apply the square roots on both sides. That's how we do it. This is how you remember these formulas here. If you ask for radius, square root of volume divided by pi r square pi h. Whereas if you're looking for height, it's volume divided by pi r squared. So definitely if you're looking for volume itself, it's the bottom part, all of it. That's how we remember those. That's how we remember the formula. Okay, we look at the second question. It says, determine and round it to the nearest gram mass of the glue in the pretty container if the density of glue is 0. So density here, they have told us that density, the formula is here, density equals to mass divided by volume. Apply, because this one here, in actual sense, it's density equals to mass over volume. You are interested in mass. What happens? M will remain and the D will multiply with the V. Let's continue question number 3.2. Question number 3.2. What are the scarce resources in South Africa? The graph below is our volume of inter-employment instance has been reduced over the years. The picture next to the graph is really fun with doing some stuff. All right. So here they're asking if I get 2 liters, the volume of water used during February 2022 by a family of 5, if each person flushing in toilet will average 4 times a day. So let's go there and you see we have told us in liters, gallons per flush before onwards. Okay, about flush water or gas. All right, this will be 1 person. Okay, we have 5. When we have 5 people, each flash is how many times? Person flashes per time. I did do the math. We shall multiply this by 1.6. We're looking at this 1.6 onwards. It may be 2023. Yep. So we see, so this is much, but then the answer that you will get, this will be gallons.
get the answer there. 20 times 1.6, you end up having 32 gallons. You have to become liters. If 1 gallon is 3.785 liters, what about 32? So you multiply by 3.785. You get comma 785. The answer becomes 1. And then they said Feb 2022. You multiply by 28. That one way in which a person can save water. This is common. Number one, avoid brushing your teeth when the water is flowing. Fix all the leakages that you have around the house, the water pipes. You have to showers and advise people to use showers than using bathtubs. But they said one reason, please. This one you cannot say that. All right. 3.3 it says Uma intends baking two milk tarts for her friends who will be arriving at 17 hours 30 minutes. So she uses ingredients and information below. She can only bake one milk tart at a time, while the first milk tart is in the oven. She prepares the second milk tart in order to put it. So you take notes. The number one, she shall need the time. How long does it take? She can only bake one tart at a time, one at a time. So you can put them all together there. So she prepares as one way. Anyway, preparation time is 30 minutes. Cooking time is 40 minutes. All right. Okay. So Uma would like to know the second milk tart can be taken out of the oven 15 minutes before her friends arrive. Uma would like the second milk tart to be taken out of the oven 15 minutes before her friends arrive. Determine the time Uma must place the milk tart in the oven. This is okay. Remember, they will be coming at 17. 17:30. So 15 minutes before they arrive. So let's work backwards. We subtract the 15 minutes. So by 17:15 it has to be done. Now this is not the time we want. Uma must place them. Determine the time Uma must place them. So remember, how long does it take? We go back here. Preparation is 30 minutes and cooking is 40 minutes. So we add those two. Because differently you have to prepare it. So which is 30 minutes. That's 40 minutes. These are 70 minutes. Which is what? 1 hour, 10 minutes. So we need to subtract 1 hour, 10 minutes from this to know when it should be prepared, when the time when it should be placed in the oven. Because it's going to take, this is 40 minutes after. Let's subtract the 30 preparation. This preparing is not yet in the oven. So when subtract 30 here, this would be so 16:45. 16:45. So 16:45 plus the 40 minutes when we need to press. We can come here and subtract the 40 minutes because this will be the one in it will take 40 minutes cooking. That means in the oven. So we say 17 hours, 15 minutes minus 40 minutes. So it should be placed in the oven at this time. That it spends 40 minutes plus 40 minutes here, it will give 17, 15, 17, 15, 15 minutes before they arrive. All right. They're telling us to convert the baking temperature to degrees Celsius, round of 2, the nearest 10 degrees. Remember, when we check up there, what's the degree? 325 degrees Fahrenheit. So they want us to change it to 325 degrees Fahrenheit. It become what? It become Celsius. So all we do, we get this number of years, put it in this formula here, which will be 325 minus 32 brackets times 5/9. Do that for me. 325 minus 32, we end up 200, 293. 293 times 5/9. And your answer becomes 162, 7, 8. These are degrees, what? Celsius. But then they say round off to the nearest 10 degrees. So when we look at the 10 degrees, this one here. So this one will becomes 160 degrees Celsius. Determine how many liters of milk woman needs to bake the 2 milk tarts. Let's go back and study this. Now this serves 8 people. Ingredients and information for only 1 tart. So they're saying for 2 tarts, how much milk? So here we have 4 cups. 4¼ cups. That's for only 1. 4¼ This is only 1. What do you do? Multiply it by 2. 4¼ times 2 gives you 8½ These are what? Cups. Now, if you don't want to write it like this, just put it in a calculator. Let me split it for you. This in a calculator is same as 4 plus 1/4, like that. Please multiply by 2 and you see what you get. Remember, put them in the brackets. Put them in the brackets. Still, it will give you the same answer as 8½. Remember, these are cups. So we need to change them. We say determine how many liters. We didn't say how many cups, but these are cups. But they have told you that only 1 cup is equivalent to 250 ml. Take note here. Remember this? 1 cup equals 250 ml. So these are 8 cups and a half. What you're going to do, get the 8 cups and a half, multiply them by 250. You get your answers 2,125. These are what? Males. You see, like they want liters. What do? We divide by 1,000. The answer becomes 2,125. These are liters. These are liters. All right. Then let's come to question number 4. Question number 4. Makes and sells bad houses and knockoff. market. Next exercise shows the diagrams of the part of the warehouse and assembly instructions. This is a single board that is 14 centimeters wide and 20 centimeters thick. To make one bird house. 14 centimeters wide and 20 meters thick. Wide is the width and the thickness is supposed to be the height. About the length, we will provide that. Anyway, this is how it will look like. And let's go to the next step. They're saying show rounded to the nearest 100 that the length of the board needed for a single bird house is 1,500 millimeters. Let's go and check on the next step. This is it. All right. Okay, this is it. We are going to remember we are looking for the length. Eh? So only here, this side here. Wait. From there to here, this is 14. That is what? That's the thickness. The width. How wide? So this short part, you see, this. You see.
You see that? I believe you see that. All right, let's start. We have the front. So the front, how long is it? It's 23. These are centimeters. 23 centimeters. You see that? The floor, it's 10. I'm taking this 10 because the 14 is already what? This width here. So the roof, it's 19. I'm ignoring the 14. When it comes to, let me side 1, side 2. Doesn't matter, we shall take the longer side. So the longer side from here up to there, this is 25. How did I know it's 25? Look at this part here. From there up to there, it's 25. Then it's the opposite. So now here we shall take the shorter side to this one here. This and this, which is 23. We go to the back, which is this one here. 14 is already taken. So simply meaning this is what? 41. Now we have placed numbers all over the length of the board. So we are going to add them up. Remember, these are centimeters. They need the answer in millimeters. Let's go and add them the other side, which will be 19 plus 23 plus 10 plus 25 plus 23 again plus 41. All right. We are going to add, we are saying we said it's 19 plus 23 plus the 10 plus the 25 plus the 23 plus the 41. Here we have it as 141 centimeters. So centimeters, we need it to become what? Millimeters, which is times 10. Multiply this by 10, you get 1,000. 1,410. These are millimeters. They say show rounded to the nearest 100 that the length of the bird needed for a single birdhouse is 1,500. We found out that we only have what? We only have, let me see, we only have 1,000. We shall add on the thickness, those lines, because those lines are going to be also taking some space, some thickness, which is 20 millimeters. So each line takes 20 millimeters. So let's come back and you see the annexure. Let's check the annexure here. All right, when you check here, we have 7 lines. We have this one here, 1, 2, 3, 4, 5, 6, 7. So if each is 20 millimeters thick, like that's distance, yeah, like this one here, that's supposed to be there. So how many are they? They are 7. You multiply by 7, you end up having 140 millimeters. All right, so we come here, add 140 millimeters. We have approximately 1,500 exact. All right. It remains say that in step 2, the 10 centimeter side of the floor will go against the back. Verify showing all calculation whether the statement is correct. Step 2. In step 2, step 2 is here. Position the floor between the 2 sides that the back and the nail and nail it in the pan. Now they're saying the position flow between the 2. Position the flow between the 2 sides, which is the sides and the back. Now the sides, let me see. We have the sides here. You understand? Why will the 10 indeed face the back? Why? It's because it's 10. The question says, show that step 2, the 10 centimeter side of the floor will go against the back. You go against the back because remember, each board has 20 millimeters thick, which is 2 centimeters from both sides. So if the back, the width of the back is 14, and we come put the sides, remember each is 2 centimeters. Indeed, this will be the tail because it will be 14 centimeters minus the 2 centimeters, which will be 10 centimeters, which is the size of the front. You see that? Because the back 2 centimeters will be taken by side 1, 2 centimeters will be taken by side 2. So how do I get the 2 centimeters? Because I told you its thickness is 2 millimeters each. So change this to centimeters, divide by 10, which is 2 centimeters. So they will eat 2 centimeters on both sides, which will make it 10. The front part of the birdhouse has a circular hole with a diameter of 4.2 centimeters drilled into it. Calculate in centimeters square the exposed surface area of the front door. Now these are 6 marks. And remember, let's go to the next year very fast. They want us to calculate the area of this part here. So what is it going to be? It will be the area of the front minus area of the hole. Let's go there. It's going to be area of the front minus the area of the hole. We are looking at the exposed surface area minus the one for the hole because there's nothing there. So anyway, let's do that and we see. Number one, we look at the area of the front. Area of the front takes a rectangular shape, so it will be L times what? B, which is, let's go back and we see from the board here, we have 23 by 14. So it will be 23 times 14. 23 times 14. And you'll end up having 322. These are centimeters squared. Done. This is the front. Together? But then this front has a hole. The hole is not covered, so it has no area. So we need to remove it. Anyway, the hole is a circular shape, so it takes pi r squared. In the scenario, they have given us the diameter, so we need to look for the r, which will be 4,2 divided by 2, which is 2,1 centimeters. So the radius is 2,1 centimeters. The radius is 2,1 centimeters. So let's come and we say 3,142, which is our pi, times the 2,1, but it has to be squared. 3,142 times 2, so here the area becomes 13,86, which is approximately what? 14, but don't do that. Now, what do? We need to subtract. So the area that's remaining will be the front minus the area that we've just got now. So the exposed area is 0, centimeters what? Squared. We might get a different answer because for me, I didn't round off immediately, but I believe you have the same answers. All right. Itumeleng paints the exposed exterior surface area of the bird. The total surface area of the bird that will be painted is this much. Wonderful. They have already given us, so we don't need to look for it. All right. He applies 3 coats of the paint according to the spread with instruction of the paint tin as follows. The first coat is 10. The first coat simply means, this simply means the first coat will cover 10 meters squared per liter. Then the subsequent coats will be 14 meters squared per liter. Itumeleng says that he will be able to paint 7 birdhouses with 500 mils of paint. Let's find out. Now, when we look at this, we shall look at only how much paint is needed for only one birdhouse together. So the first coat, it takes this much. So how much are we going to take there? So how much paint do we need for the first coat? So the first coat, I'll write it as F1. It will be, I'm looking for the amount of paint that I need to use. I'll divide by 10. Why am I dividing by? Because I need to find out, because only 1 liter covers 10 meters squared. Here we are. But remember, these are 4. Let's multiply it for 7 beds. I'm picking it from here. The 7 comes from here. So let's see. 0, 2, 888 times 7 divided by 10. These are the liters that we shall need. But mind you, these are liters, and we are looking at what? Mils. So change this to mils. So here we need, these are mils. We go to the second, which covers 14. The second part, 14. But remember now, this is going to, because they said there were 3 quotes. The first quote only needs that. That means the others will take this. So we shall say 0.2888 divided by 14. This will be multiplied by 2 to be multiplied by 7. Why? There are 2 quotes and there are 7 bad houses together, which will end up giving you 0.2888. These are liters. We want them to become mils. What do? We multiply by 1,000. The answer becomes so we add the 2 to find out. Yeah, don't forget to say it's what? He is correct. He is right. He said the service would be enough 500. 4.3. Itumeleng has the following expenses for the house. Itumeleng has the following expenses for the bad houses, which is number 1, rental of the store at the flea market, which is 250 per week. Transport 100 per week. Wooden boards, it's that much, 287 rands 40 cents for a band of 6 boards. Paint, which is 21 rands 40 cents per house band. Then sunrise, which is 10 rand 70 cents per house. And next year, this shows the graph representing Itumeleng's weekly income and expense for the bad houses business. This is supposed to be the paper. Anyway, so there we go, and we shall say show how the value of 350 fixed weekly cost was calculated. We shall come here and say rental, this is per week, it was good there. Transport per week, it was good there. Nothing else per week, and it's not fixed. So here we shall come and say if they took the 250 rands plus the 100, 300 and what? 50. That's how they got the fixed weekly. And they told you weekly. So how many weekly costs do you have? There are only 2. Okay, calculate the value of P, the variable cost for making one bad house. The value of P. So what you're going to do for me is here. Let's go and you see the next year. The next year is here. So this is the expense that we're going to start with, because the fixed amount is somewhere here, which is already what? 350. but they want us to calculate the amount. Now, what you do, let's see, this is 0, that means this is 1, 2, this is 3, 4, this is 5, 6, this is 7. Anyway, you can go on and go on, but then what you do, you check, I've already seen it, where the line touches another line exactly to give you a certain value. Look at that, this one here. So for 3 birdhouses, I'll write the BH. They give you how much. You need to find out. Let me see, how many lines do we have here? We have 1, 2, 3, 4, 5. Each represents 100. So for 3, you pay 600. For 3, you pay 600. Remember, we are looking for the value of P. Now, if you produce 3 birdhouses and you spend 600, how much is each? What you're going to remember, of this 600 is a fixed weekly cost. So it will be 600 minus 350, which becomes 250. 253 divided by 3. Which is approximately 83. 83. But if not, these are the variable. Okay, let's see. We shall come here, 200 this divided by 6 plus paint per birdhouse, okay, plus 21 comma plus the 10,70. Together, do that for me, 287,80 divided by 6 plus 21 rands 40 cents plus 10,70. Here it gives you 8. It gives you 8. Gives you 80. The variable cost, or the value of P, the variable cost of making one birdhouse, you shall take the amount that's used to buy the, remember, only they use one board for each birdhouse. So we shall write 287 rands 40 cents. We divide it by 6 because we need how much is only one board. Divided by 6. We get this money as 47 rand 90 cents plus 21 rands 40 cents. That's the money for each house. Then the sun rice, which is 10 rand 70. When you add everything, you end up having 80. So our P will equal to that much. Explain the break-even point in context. Now, this is when you say break-even is when the costs of making one birdhouse equals to the income of selling one birdhouse. Or you can say this is when this is when income, not profit. you can say to an income equals to the expense of making one bad house. During 1 week, if Mailing makes 15 beds, but he only sells 12. Show by means of calculations if he made a profit or a loss. If he made a profit or remember 15. To make this 15, how much does he spend? So we are looking at what? Expense. And we've already seen that expenses are, we shall to get the expense, we shall say 550 plus. Now we've got the value of P already, which is what? 80 rands. So put there the 80 rands times 15. That's 15 times. So this is the expense. So if he comes and he only sells 12 of them, let's see how much is the income. Let's go and you see the, let's go there next and you see the income. Income, I can get it from here, I believe, because it's 1, 2, 3. So each is 150. So here you come and say 12 times 150. It's 1.8. So we say he made a profit. Let's look at the graph also. 12, he sells 12. Indeed, he makes a profit. Look at where 12 is. It's already past. Look at this. It's already past what? The moment, if the value is this other side like this from here, that other side, this is what? Profit. If it's this other side, after before the break-even point, this is a loss. So this triangle here represents a loss. That's a loss. This triangle here represents the triangle here represents a loss. And this way, this one represents profit. Represents what? Profit. So this is a loss. And here we have profit. So if the number that you're looking at is from here, at this one here at 5, we don't have profit, we don't have what? Losses. At 5, it's when it's break even. You want to prove it, you can say, remember the cost, the expense they said is 350 plus 80 times the number of houses. Now we have 5. How much do you get? 750. Then what about if you to sell? This is what? Expense. What about income? Each is sold at 150 times 5. You get the same answer as what? 750. So here, yeah, indeed, this is a break-even point. How did I get the 150? It's the income. How did I get it? I just came here, took the 2. When does it touch? Because this line here, the dotted line is the one for income. I saw it touches it here. So I needed to read off this value here. 2. They cost how much? We took our lines. We have one line here, 2 and 3. These are this is what 300. If 2 produce 300, what about 1? So we divide this by 2. That's how we go to the 150. All right, let's look at question number 5. Dan and Susan are on their way to visit one of the tourist locations in Japan. Show a road, okay. And next year, E shows a road infographic of their planned tour with the various tourist locations that would be visited. There we go, and you say tourist locations details in a random order for the tour are given below. These are the sum of we have them there. What I see here, I need to note it. I see some speed here. Okay, it's fine. Here they're telling us to complete the table. Complete the table below by inserting the tourist location details in the correct order. Let's go and see the next year. This is the next year they have given us. Actually, yeah, road infographic of Japan. So A, start in Tokyo. Visit Mountain Fuji. Mountain Fuji. Visit the world's largest aquarium to see the different types of fish in Osaka. At Nare, they plan to visit the largest student temple in their park. The trip will end in Tsukushima, which is known for great corrugate that is standing in the water at high tide. Location details are from 0 to have been given below. Complete the table by inserting the tourist location details in the correct order. So 1, they said start with it's Tokyo. Number 2, it's going to see number 2, it's the number 3 to be the Fuji. Mount Fuji. Oh, no, we need to use letters, not words. Okay. This is B. 2. Let's go to 2. aquarium will be 5. 5 is C, A, B, C. The wooden temple, this one here is at 4. So we come here, we see the plant which is D. So definitely which is remaining is A, B, C, D, E. Then we have what? F. One, A, F, B, D, C. Mount Fuji is an active volcano. That volcano eruption in 2017 and is followed by several weeks after an earthquake. Calculate how many decades ago Fuji erupted. This was 20. Okay, let me use 2022 minus the year when it erupted. How many decades? They're asking us how many. Remember, a decade is a collection of 10 years. So 2022 minus. I'm using 2022 because the paper was done in 2022. So we end up having 350 divided by 10. So approximately they are 31 what? Decades and a half. 31 decades and a half. Write down the total number of days between the earthquake and the last eruption. So if these are years, we shall multiply by 365. Which is 114,975 days. In Tokyo, they will visit Tokyo Tower, which is a communication and observation tour. Observation tower. The tower is let me see, 1,092,91916 feet tall. It has 2 viewing decks. The main deck is 150 meters above the ground, and the top deck is 250 meters above the ground. Some of the tickets priced by personnel are shown below here. Design here. Write the simplified form of the ratio of the height above the ground of the main deck and the top deck. The ratio form. Simplified form by 5. By 50 remain with 5. Convert the meters and the height of the tower. Convert in meters the height of the tower. If 1 meter is equivalent to 3,281 feet. Remember there we saw it was 0 to 1,092, 1916. So we need to divide this by that much. the meters. Then it stated that if they had been in a group of 60 people observing from the main deck, they would observe, they would have received 30% discount on adult tickets. Verify whether the statement is correct, showing all calculations. Showing all calculations. I said that if they had been in a group of 60 people observing from the deck, they would have received 30% discount. Let's verify, and you see, here we are, adults, yen, top deck, group reservation for main deck, it's 20 people or more, but less than 50. So the main deck group reservation, main deck group of 50 or more. This would be 60. That's that if they had been a group of 60, that's 60 times. That's the money they would have paid. But then, remember, these were only two people. They were not in any group. Danny and Susan. They are away. So there are only two people. Simply meaning they fall under adults 19 years and old main deck. Oh, okay. Let's not, because there are only two, so let's count for only two people. We shall not. This simply means the person would have got a discount of that much ABC. So it would be the money they would have paid each, or let's say 2 times 1. This is what they paid, which is 2.4. And if they were in a group of 60, they would have paid how much? $1,920. So let's find the percentage, simply meaning 2,400 minus 1,200 divided by 1,200 times 100. Looking at the percentage change. Which is 25%. It's invalid. Invalid. Number one thing, if you're going to calculate speed, this has to be in your head always. If you look at the formula they have given you. So in your head, you should always know that speed equals to distance over time. So ask yourself, do you have the distance? Distance the train traveled, it's this much. Divided by time. Time has to be in hours, but then take note. The train left this station here at 8:06 and it arrived at this much. So you look for the time minus the time when it was stopping because it was not moving. So there's no speed there. Anyway, look for the time. Number one thing you're going to do that for me, please. We are subtracting how much time they spend on the journey, which is 12 minus. So they spent 3 hours 57. If you don't know how to do this, please, all you do is 12. So we borrow here in that this time becomes what? 60. 63 minus 6, you get 57. Then here you're remaining with what? 11. 11 minus 8, you get 3. So this is the time they spent on the road, but we need to subtract the time they spent stopping. So 8 stations, each station is what? 4 minutes. Those are 32 minutes. It's subtract. So they spent 3 hours, 25 what? Minutes. This has to be changed now to this is the time the train was traveling. So we need to change it to everything. We need to change everything to hours. So already these are 3 hours. We don't need to change them. Plus, we need to change the minutes to hours. We divide by 60. 3 plus 25 divided by 60, which is 3,4. Now everything has become hours. So now we are good to go. We can come and bring it here to know the speed. So all of them, when you look at them, they indicate a quarter to. So the best answer here is Z. All right. Name two time formats used to display time on the clocks. Now, as I told you, there are 2 of them. You either call it analog. Let's look at question number 8. Number 8, it's a floor plan. When you look at the floor plan, actually a floor plan is a layout of how a house will look like in the future. All right? It shows where the kitchen will be, the bedroom, toilet, living room, the garage, if there's a garage, what's there. That's a floor plan. It's a floor plan, a major layout of. All right. RDP houses are built to assist low-income earners. RDP houses are built to assist low-income earners. RDP houses are built to assist low-income earners with proper houses. Mr. Nyandeni visited Uruduwai Unit L to check the progress of the construction of his parents' home. The floor plan of the house. Now, this is how the house will look like. All right. That's how the house will look like. Take note, we have a compass there. These are measurements. These measurements are in millimeters. Okay. Determine the number of interior doors shown on the floor plan. Interior, those that are inside. So we shall start by saying, interior doors. Interior doors, we have 1, 2, and 3. 1, 2, and 3. Say. RDP houses are built to assist low-income earners with proper houses. Mr. Nyandin visited one of the units to check on the progress of the construction of his parents' house. A floor plan. What's a floor plan? A floor plan, we always say, it's a layout of how a house will look like. All right, probably it might have a campus. Some others have scales, depending on which kind of floor plan is given to you. So we have measurements. These are measurements that we see on top. These ones here, but they're in meters. All right. We look at question number one. Question number one says, determine the number of interior doors. Determine the number of interior doors that are shown on the floor plan. Interior simply meaning the ones which are inside. So we have one that's inside, two, and three. So we have three interior doors. So here we have three. We have three doors. Give the general direction of the bedroom one from the living room, meaning you're in the living room, you're going to bedroom one, living room two, bedroom one. Yes, this is our campus. The campus has north, so this is west, south, and east. So if you bedroom one from the living room, that means if you're in the living room, where is bedroom one? So bedroom one is in the northeast. Our general direction here is northeast. Name the room that has the same floor plan as bedroom two. The same floor area, same floor area as bedroom two. Let's come here. Bedroom two is 3,550. These are millimeters. What about this side here from here to there? What's the bedroom? Let's go and we see. Oh, it's the same. It's the same. 3,550. So this is bedroom two. So we are looking for a room that has the same measurements as this. Same measurements. Let's come. We shall start with bedroom. Living room. Yes, living room. Yes, it has this much. What about from there to here? What is it? We check up. Oh, it's the same story. So one of the rooms, we can say living room. Let's see. The kitchen, no. This number is different. Bedroom two. This number is different from this. So the living room shares the same area as bedroom two. Living. Give the names of the rooms that are facing west. In other words, those ones that are on the western side. On the west, we said this is west. So if you draw a compass in here, you draw the compass in between the house. So which one is in the west? These are the rooms. We have the kitchen, the toilet, and the living room. We shall say, we said we have the kitchen, we have the bathroom, call it the toilet, and we have the living room. Sorry, 8.2. Study the sitting plan of a airplane below. Study the sitting plan of the airplane below that is going to be used by Kubeka's family when traveling from Durban to Gauteng. Sitting plan of the airplane, it's this one here. Define the sitting plan. So here we shall say sitting plan is the drawing show sit in the airplane. Showing sits in the airplane, it's a drawing showing. You can say it shows the sitting arrangement of how people are going to sit. How many exit doors are indicated on the seating plan? Now, unfortunately, we don't see any symbol to show, but the exit doors we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 exit doors. 8 exit doors. Write down the number of passenger seats in the plane. Oh, so here we go, number of passenger seats in the plane. Now, what do you get? This was just showing you that this is column A, B, C, D, E, F, but still these are seats. Eh? So we're going to count. We shall see 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 3 plus 9 again times what? 3. This is the first class here. Then we can count these ones. 1, 2, 3, 4, 5, 6 plus 6 plus, let's count 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 18 times 3 times 2. We're going to add up all the seats now. So 9 times 3 times 2, we have 54. 54 plus the 6 plus 18 times 3 times 2. This is 60 plus that, which is 168 seats. 168 seats. All right. 8.2.4, the actual length of the airplane. Actual length of the airplane from the cockpit to the passenger cabin is given as below. As 50 meters. So the scale of the plan is 1:200. Calculate the length of the plane on the plan. Plan, this is what? Paper. Then actual, the moment you hear the actual, this is in what? In real life. So we call out the scale, which is 1:200. The left is on paper, and the right is in real life. So in real life, this plane is 50 meters. What is it on paper? You remember on paper, we should all have millimeters or centimeters. These are meters. We are going to cross multiply. Cross multiply 200 times A. You get 200A equals 1 times 50. Remember, these are meters. So since we're looking for the value of A, we divide through by 200. Divide through by 200. So the A equals to, this is 0.25. These are meters. Change them to millimeters, multiply by 1,000. The answer becomes 250 what? Millimeters. If you wanted them to become centimeters, it would be 25 centimeters. Mr. Kubeka's son has been allowed to has been allocated a seat in the 8th row, second column. From the left, name the seat number he will be seated. So they have told us eighth row, second column. So these are columns. When we go down, these are columns. Then these are the rows. So we are in row number 8, second column. So it's supposed to be here, which is what? B8. You see? So the city number is B8 on the left. That's what they say. So it's B8 on the left. From the left. Mr. Kubeka's wife wants to sit in any seat next to the window. Mention one reason why she chooses to sit next to the window. One, people like it when it's to view. To view what? To have a clearer view. Others might sit there. In case of emergency, they can easily escape. All right. Give one possible reason why Mr. Kubeka decided to use airplane to travel to Gauteng. Advantages of using an airplane. Aeroplane. It's supposed to be one, it's fast. Two, it's convenient. It's convenient. Three, comfortability. Among other reasons, you pick one. Why would you use a plane over a bus? The family left King Shah Airport at 9:30 and arrived at OR Tambo at 10:40. Take the average speed the airplane was traveling at if the flight distance was 478 kilometers. One, we need to know how much time was because we are going to calculate speed. And remember, speed equals to distance over time. We already have the distance, it's this much. What we don't have, it's what? The time. So time will equal to the duration they spent, which is the end time minus the start time. The end time they ended or they arrived at 10:40 minus 9:30. This is 1 hour and 10 minutes. 1 hour, 10 minutes. So we change everything to hours. So 1 hour plus 10/60. What do you end up having? You have 1,1666 recurring. I will leave it like that. So these are the hours they use. This is the time. So here we go. So speed now, we have the distance divided by 1,167 as our time. It's the speed of the airplane. We look at question number 9. Architects make use of models of buildings so that they are able to sell their ideas as well as convey what the building will look like once it has been built. The diagram below shows the gable roof and the net diagram of the small tuck shop. Use the diagram and the information above to answer the questions that follow. The gable roof structure, this is how it looks like. This triangle part of it, that's what we call the gable. And the net diagram of the gable house is how it looks like. All right. If the net diagram was constructed using a scale 1:250. Was the net diagram going to be bigger or smaller than the above net diagram? Definitely it would have to be bigger. Why? 250 is more than 100. So simply meaning the diagram will reduce or enlarge by 250. So here we say it's gonna be big. 250 versus 100. So 250 is bigger than 100. If it was less than 100, then it would be smaller. Use the scale 1:100 to determine the actual length in meters of the length of the tuck shop. Let's go and we see. The length of the tuck shop, I believe it's going to be from here to here. These are walls that are going to be standing up. So we cannot add also 24. 24 millimeters. This will be the height of this part here. From here up to there, it's 24. Because if you fold from here up to there, it's the length, which is the 70. So when you fold this upwards, so this becomes the length, this becomes up, this becomes the height. This from here up to there, it's the breadth, which is 50. So from here up to there, it's the 50 millimeters. All right. They want us to change the length into actual. So we said left is always on paper. The left-hand side is always on paper. Then 100 is the actual measurement. So if on paper it's 70, on paper it's 70 millimeters, what will it be in actual sense? We don't know. Let's leave it as a cross multiply 100 times 70 will give me the A that we are looking for. But remember, these are 70 millimeters. So the answer you get here, this will be 7,000 millimeters. Why? We had millimeters. But we don't want millimeters. We want it to be actual. So millimeters, change them to meters. Divide by 1,000. And the answer becomes 7 meters. 7 meters. All right. If the gable has 0.5 meters hung on either side, determine the value of A, the actual width of the one side of the gable tuck shop. So here we are. So they want us to get this side from here up to here. But remember, it has a hang, like it goes off the wall a little bit. This small space here that we see from here up to there. That's what we call the hang. Together. But how big is it? In actual sense is 0.5 meters. So what about if it's from here up to there before the gabi? It's this distance that we have here. So it's millimeters. But remember, this is on what? On paper. And the question wants you to have the actual. So you should change this to actual using the same scale that we have here. So let's go there and we see. Shall say 1:100. What about the 26.93? What will it be? I'm changing it to actual length. So we shall multiply that, which is 26.93 times 100. So this will become 26.93. These are millimeters. Divide by 1,000 becomes meters, which is 2.6. This is only one side. So we add on the 0.5 meters, which will give you 3, gives you 3, 3,193. 3,193. These are the meters. This one why I'm giving you in meters, they wanted the actual width. All right. Here, I had to change it to actual. So this is it. Then I changed it to meters. I added in a 0,5 there. All right. We look at packaging. Packaging, this one we call it lengthwise and this is widthwise. All right. Oh, we shall see what we go. Okay. Packaging. A company produces rechargeable LED lantern lights and packs them in small rectangular boxes as shown below. The small boxes are then packed into large boxes for transportation. Pictures of small rectangular boxes. This is how it looks like, the picture, not the diagram. Now, these are the diagrams. These are pictures. Okay, the dimension of the boxes. The big box has a 60 centimeter width of 48 centimeters, height of 24 centimeters. Small box has a length of 22 centimeters, width of 12 centimeters, and a height of 12 centimeters. The small boxes are packed into the large boxes using these two options. When you look at option number 1, the length of the small box, we shall call it LS, is facing the length of the big box, which we shall call LB. So if you're to find out how many small boxes, because here we're going to find out how many feet on the long side, how many feet on the short side. So they're saying verify using calculations which of the two options will be most cost effective to pack in the small boxes. Cost effective simply meaning it will be less expensive. Less expensive. In other words, it has to take more small boxes. Cost effective, we are looking for more. Which option would take more small boxes? That's what you're looking for. Anyway, let's start. If you're to use option one, we are taking the length of the bigger box divided by the length of the smaller box. What do we have? So we go back and we remind ourselves, the length of the smaller box is 60. The length of the smaller box is 22. So we shall come here and we say 60 divided by 22. What answer do we get? It's 2,727. But we can't have a comma box. So here we shall need 2. All right. Then we go to how many will fit on the short side from here to there. How many will fit? Because we've already seen from here up to there lengthwise. We've already seen that. What about the width? So width we shall say width of the bigger box divided by the width of the smaller box, which will become 48 divided by 12. 48 divided by 12. 48 divided by 12, which is 4. So on the short side, we shall take 4 there. What about height-wise? When we go up, so it will be height of the big box divided by the height of the smaller box, which will be, here we are looking for how many layers. So it will be 24 divided by 12, which is 2. So option 1, all in all, how many boxes do we take? We take 2 by 4 by 2, which gives us 16 small boxes. This is option 1. Let's look at option 2. Option 2 changes a little bit because now we see the width of the small box is facing the length of the bigger box. So how are we going to get how many are going to fit here? If I take the length of the bigger box, divide by the width of the smaller box. That's what we are going to do. So here it changes a little bit. Length of the bigger box divided by the width of the smaller box. Length, we said it was what? 60. Width of the smaller box is what? 12. It becomes 5. Continue, we shall say here now width of the bigger box divided by the length of the smaller box, which is 48 divided by 22. The height will remain height of the bigger box divided by the height of the smaller box, which became 24 divided by 2. Answer became 2. 48 divided by 2, we have the answer as 2,1818. So here we only have 2 boxes. So in option 2, we have 5 by 2 by 2, which is 20. 20 small boxes can be packed in option 2. So option 2 is cost what? Effective. The picture below shows 30 trolleys the company uses to transport large boxes to the delivery vans packed. So these trolleys are packed in 3 columns by 10 rows. So 10 of them they pack. So in other words, these are 30. Because if each column has 10, 3 times they are 30, all in all. Anyway, so the one has to find out how many, the 30 trolleys are packed using 3 by 10 arrangement. Calculate in meters squared the floor space needed to store the trolley. You may use the area because, so first and foremost, we need to find out the length because it's not given, and we shall find out the width. So the length will be longwise, like from here going that side, and width-wise it would be from here coming this other side. So we shall look first and foremost length. Mainly they are 10, but each will leave a space of 30 centimeters. You know, they are packed into each other, 30 centimeters. So 9 of them, it will be 96 plus 30 times 9. Why do I get 36? Because each has 96 centimeters, which is okay. So one of the trolley, it will have to maintain its length. But then when they enter inside each other, they leave a space of 30 centimeters each. So how many trolleys are going to enter into each other? They are 9. So the lengthwise, it will be 96 plus 3 times 9. So the length will become 366. These are centimeters. Yes, sir. So that's the length. What about the width? The width when they are packed like this, that one will be so simple. Why? Each will take 50 centimeters. 50, so it becomes 50 times 3, which becomes 150 centimeters. Take note, the area is supposed to be in meters. What do? Change the length you've got into meters, change the width into meters. So our length now becomes 3,66 meters, and the breadth becomes, or width becomes 1,5 meters. So area will equal to 3,66 times 1,5. 5,9 meters squared. 5,9, 5,49 meters squared. That's how we get it. Use the actual length in option 2 to determine the scale in the form of 1:2. I'll give you a number. If the measured length is 8,5 centimeters. Now we are determining the scale. The scale we are determining is a ratio scale. Remember, ratio scale has the left and it has a right side. So the left, it's what we have on paper or on the plan. And the right, this is what we have in actual sense. You understand? So on paper here, they have told us they measured 8,5. These are centimeters. Are equivalent to, in real life, we come here, we say option 2, which is this other side. It's 25,5 meters. 25,5 meters. So the big unit gives to the small. So the meters have to change into centimeters. So multiply by 100. So remain with 8,5 is to 255. But we need it to start with a 1. So we divide through by 8,5. 8,5. Here, this goes, you remain with 1 is 2. This is 300. Sorry. Sorry. It's supposed to have a 0 here. Divide by 8,5. We have the answers. The scale is 1 is 2. 300. This is the answer. 9.4.2. Mr. Andres intends to use the option with the minimum square meters. Use the calculation to determine which option you will recommend. Minimum. Which one has the smallest area? So Andres to choose. So here we go. These are the diagrams that you're looking at. Option 1. If you are to look at option 1, it has how many sections? It has 1, 2, 3, 4. But they all have the same units. So what we're going to do, let's look at area. Only one section, which will be 6,8 times 10,6. We put it down and say what answer do you end up having? This is only for one section, so multiply it by 4. So option A takes 288, comma, the rate 2. These are meters what? Square. That's option 1. Let's come to option 2. Option 2, it's already measured. Everything is there. So it's pretty straightforward. L times B, which is 25,5 times 9. Which is 299. 229. 229, comma 5. 229, comma 5 meters squared. So which option shall we have? It shall have option 2. Option 2 will take a minimum space. So here we are doing question number 9 point. So here we say which option? We shall say option 2. Determine the number of wires to be connected in the plug. Let's look at this one. So this other question here. Wires. Now each part that you see here, this is a wire. You have 1, 2, 3, 4, 5, 6, 7. So there are 7 wires. When we come to this, write down the number of plugs that should be connected for the stop lights. The stop lights, you come here. We have one stop here. The stop lights, you see it? Any other? There is no any other. So we shall say it's 1. Identify the color of wire from the rear fog lights. Rear fog lights. We say it's what? Blue. Explain the importance of the tail lights on through. It's to indicate for the 9.6. Purity cereal box has the following dimensions: length 14.5 centimeters, breadth 5 centimeters, and the height of 193 millimeters. Inside the box, there is a foil bag containing the cereal. The length of the bag is 96.55% of the length of the box, and the height is 7% shorter than the box. The breadth of the bag at the bottom is 4 centimeters. Below is a picture of the net box opened up. Use the following formula. Calculate the amount of cardboard in centimeters needed to make one box. Now, here we go. The net is the sketch of the diagram. So this is what we need. So we're going to calculate the length, total length. It would have been,
You would have used surface area, remember that? Which is 2 into L. But this one here is a different. I've given it because now this surface area does not get a good. This one is twice also here. So this one does not work here. Anyway, let's continue now. In our mere understanding, we shall have to say that we need the area of C, but how many times? So C, it will be 4 times, 4 C's, plus how many D's do we have? We have 4 D's. You see that? Then we go on and we say the C's are already there. The C's are already there. Then the B's will be 2 B's plus how many A's? We need 2 A's and 1 E. That's what we need to know. But they have already given that if you only have 1 C equals to this much, if you have 1 D equals to that much. All right, let's go and see. But they didn't give us the area for A and the B. All right, so we are going to do that. We are going to add them up. First and foremost, we may look for the area of A. Because I'm here looking, because this is length. So, but remember they told us the length of the box is 14. 14, these are centimeters. The height will be 19,3 centimeters. So area of only A, area of A will equal to L times B, which is probably 19 times 10,5. That's A, right? Area of A is the centimeters, right? Squared. That's A of A. Then we go to area of B. B, we are going to analyze it also. This is breadth from there to there. Then the height. So what's the breadth? When we come here, they told us it's 5 centimeters. So area of B will equal to 19,3 times what? 5, which equals to 96,5 centimeters squared. So we have, now we can continue now and we substitute. What we need to know is calculate the amount of cardboard in centimeter needed to make one box. That's what so we are going to add all the areas of all these small pieces around. All right. So I'll start with, we say, we analyzed that we need 2 A's. So I will say 2 times the area of A, which is 279,85, plus we need 2 B's. 2 times the area of 96,5, plus how many C's do we need? We need 4 C's because we saw we have 4 C's here, né? So it will be 4 times the area of only 1 C, which is 43,5, plus how many D's do we need? We saw also there are 4. This one here we have 1, 2, 3, 4. So we say 4 times the area of only 1D, which is 12, plus what's remaining now? We finish the B's, we finish the D's, the C's are finished. E, it's only 1, and they have told us it's 11. It's 11, 6. Put this in your calculator and you see what you get. When you put everything in, you get that much. 988.3 centimeters squared. Okay. All right, now let's look at this. 9.6.2. The cardboard is cut from a sheet that is 90 centimeters by 90 centimeters. Determine the number of boxes that can be cut out of this sheet. Assume that 3 centimeters, C is 3 centimeters wide, and E is 1 centimeter what? Wide. So we are going to cut this. 1 centimeter wide, and here we have 3. So we need to know if you're to how long will it be if you're to add it up like that from top to bottom. How long is it going to be? Sorry about that. And how long will it be like this? You know, you've not considered those cutting small ones. So I'm here looking at this. This is already what? 19.3 centimeters. Then on top there we have, they told us it's 3 centimeters wide. Also bottom here we see 3 centimeters wide. You know, this one we are taking 3 centimeters wide because this one is shorter than, so everything is combined into one. So what about how long will it be? So we shall start with this one portion here. 1 plus from here up to there it's 14. Then from here up to there it's what? 5. Then again another 14 plus another 5, which becomes 1 plus 2 into 14 plus 2 into 5. Understand? That's what we need to know. So lengthwise, what's the length and what's the width? This will be the width. Right. So the length will be 1 plus 2 into length equals to 40. Whereas the width is going to be 19.4, 10.3, sorry, plus 6, it's 25, the width is 25.3. The reason why I need to do this because these cuttings will appear there, yes, well and good, but how many, if it's a full box without a cutting, how long is it and how wide will it be? So now I'm good to go. I'll go. Yeah. Lengthwise 90. divided by our 40 that we saw. So 90 divided by 40, you have 2,2. In other words, on the long side, we shall only need 2. Okay, remember the sheet is 90 by 90. So the other 90 is going to be divided by our width, which we saw as 25,3. 25,3. So 90 divided by 25,3. Yeah, we end up having 3,56, which is what? 3. So all in one sheet, we shall need 2 times 3, which are 6 what? Boxes. 2 on the short side, 3 on the long side. All right. The sheet of cardboard costs 5 rand per meter squared. Calculate the cost of making the number of boxes that you calculated it. 9. So remember each, okay, we said there are 6 boxes, but each takes an area of an area of that much, which means it covers an area of 592. These are centimeters what? Squared. They are charging in meters squared. So we change this to meters squared by dividing by what? 100 squared. That's much that they need there, times 5 rand. The answer becomes around 96 cents. All right, here we go. In order the company to save money, the difference between volume of the box and the volume of the foil bag must be 350. Must be between 350 centimeters cubed and 400 centimeters cubed. Assume the foil bag has a rectangular prism. Verify by showing calculations. So we are looking at the difference between volume of the box and the volume of the foil. So for the box, we need to put it down. We are saying it's L times B times H. But let's go up there and we see these are the measurements of the box. As you see there, 14,5 as a length, 5 as a breadth, and the height of 193 millimeters. So we shall come here and say length 14,5 times 5 times 19,3.
Remember, the height was 190 millimeters. We want it to become centimeters. So we divided by that and we got this answer. So this is the height. That's why we have this much. So put the answer down there. So the volume we have here is what? 1,399, these are centimeters what? Cubed. Then volume of the foil. We need length, breadth, and the height. But when you look at the scenario they have told you, the foil one, they are talking of the length of the bag, the foil bag, foil bag. So its length is 96.55 of. So here we shall say its length is 96.55 times the length of the box which you have. You go to the height. The height, they say, the height of the box is 7% shorter than the box. The height of the box is 7% shorter than the box. The height of the part is shorter than the box. So simply meaning, if 7% shorter than the box, that means it's 93% of the height. So we shall come here and we say 93. Remember, this is percentage, 93% of the height that we have, which is 19.3. Then the breadth, they said, the breadth of the bag is of the bottom is 4 centimeters. So here we are saying the breadth is 4 centimeters. This one don't need to change. So we need to look for this. Look for that. 93 to 96 times. Divided by 100. So the height is 13.97, which is approximately what? 14 centimeters. So the height is 17.95 centimeters. So the volume of the foil will become now 14 times 17 times the 4. We have 1,005.2 centimeters what? Square. I don't know how we are looking at the difference between the two. We shall subtract foil. It's 394, comma. Yeah, it's fine. Satisfies. You can say it. Satisfies. All right, let's go through paper 2. Prelim paper 2. Okay, we got the questions. Where are the instructions already? We have some diagrams here, which are instruments. Question 1, 1.1. The images below represent measuring instruments used to measure mass and volume. Study the image below and answer the questions that follow. A, okay, match the descriptions below with the image above. Write down only the correct letter A to D. An instrument used to measure the mass of meat in the butchery. This has to be C, what we call the electronic scale. So this is C. All right, we go to an instrument used to measure mass of different food types in the kitchen. This had to be B. It's B. Then an instrument used to measure liquid. It's a jug, which is D. And an instrument used to measure body mass of a person. So this electronic body mass scale, which is A. So we have the answer supposed to be C. The answers were supposed to be C, C, B, D, A. We go to the second one, 1.2. The bathroom scales may be used to monitor one's body mass index. That's about a bathroom scale with a radius of 15. Define radius. We can say radius is half of the diameter. You know, for radius, we have different answers. Or someone can say it's the distance from the center of the circle to the circumference of the circle, like this. From the center to the end of the circle. That one would also be. So now they are telling us determine the diameter of the bathroom scale. Now, remember, radius is half the diameter. So if radius is half the diameter, what about diameter? Diameter means it's 2 times the radius, and which will become 2 times 15. And the answer here, you got it as 30 centimeters. Don't forget the units. This is paper 2, and we are looking at measurement. Convert 15 centimeters to meters. Convert 15 centimeters to meters. Remember very well that we are dealing with metrics. No one will give you the conversions here, but you know very well, changing from small to big, we shall need to divide. Small to big, we are dividing from right-hand side to left. So this is 15 divided by 100, and the answer becomes 0.15. These are meters. Don't forget the units. Let's measure measured his height, and the reading is 66.929 inches. Determine the height in meters. They have already told you 1 meter is equivalent to. So if 1 meter gives me 39.37 inches, what about if I have 66.92 inches? What will they be? I call it B. So I cross multiply, simply meaning I will need to divide, which will become 66.92 divided by 39.37, and the answer becomes answer becomes 1.7. The answer is 1,7. Don't forget, these are meters now, from inches to meters. Yes, here I want you to remember that we looked at kilometers, meters, centimeters, and millimeters. Remember, in between here we have 1,000, here we have 100, and here we have 10. So that's where I got the 100 from, this 100 that I'm using here to divide. Okay, choose the letter of the answer that will complete the following statement correctly. The unit used to measure BMI is, it's B. Why do we say B? Because it's mass over height. But the height has to be in meters squared, and the mass has to be in kilograms. So this is per. So which is B. 1.3. Let's download the seating plan of a plane to check the seating, to check the seat that you reserved for a trip. Use the information in annexure A to answer the following questions. All right. When we look at the point, when they remember they asked us to give the okay. We are looking at what we call the, let's take it indicates that the person was seated allocated sixth seat in the east. Take note of that, in the east. So how will you know the east? We shall use what we call the compass and identify the seat. So let's go to the next chart. This is our next chart. This is the compass that we have. So when you look at the compass, it shows that this side here, this is the north. Definitely, the east has to be up there. This is, if this is the north, then the east is that side, then this is the west. So the east is on top here. So we need to count the step with the seats. We say 1, 2, 3, 4, 5, and 6. We are looking for the sixth place. So our answer there becomes 7, 8. Use the cardinal points where the toilet is situated. The cardinal point to determine where the toilet is situated. The cardinal point, when you look at the cardinal point, we are looking at north, east, west, and south. Cardinal points. Cardinal points. North, east, west, south. So in which cardinal point is the toilet? The toilet is here. So the cardinal point here is what? Because this is north, then the toilet is in the west. How many seats are on the plane? We go to the next chart. How many seats on the plane? Easy mathematics. Here we have, okay, this is what 6. So 7, 8, 9, 10, and 11. But how many complete like this? There are 3 of them. So when we come here, we shall say 3 times 11 plus 1. This one here. So it's 3 times 11 plus 1, which becomes 33 plus 1, which is 30, 34 seats. 34 seats. Then we go there and say, determine the number of single seats from this plane. The number of single seats. So these are the single seats. The number of single seats. Single seats. So what's the number of the single seats? So here we have 11. They are 11. We have it as 11. Single 6. What is the general direction? What is the general direction? What is the general direction? What is the general direction of seat 12 from seat 6A? General direction of, so we shall go there next year. Let's go to the next term. They're saying general direction of seat 12, 12A, seat 12A, seat 12A, room, room. So the person is in seat 6F, heading to 12A. So shall go to 6F. 6F is here. We draw a small compass. Remember, this is north. North, that's east, west, and south. So we are heading to 12A. So 12A. 12. So this becomes northeast, becomes northeast, and we shall see that here. It's northeast. Express as a ratio. Express as a ratio. The number of double seats to the total number of seats. Now, since we saw that there are 34, since we saw that there are 34 seats all in all, let's remove the single seats. So remain with the 23. So we go for the ratio now. We say the number of double seats to the total number of seats. So it's 23 versus 34. 23 versus 34. That could be the ratio. Oh, sorry. Single plus the 12 one. There are 12 single seats, sorry. Remember, we have all these from up here. These are single seats, including the C. So they are 12, okay? 34 minus 12. 34 minus 12, we end up having 22. So it will be 22. 22, 22, 22, 22 versus 34. So by 2, you get 11. By 2, you get 17. That is question 1.
Something I'm not
Sorry. We look at question number 2. Tandy lives in George, and she travels to Port Elizabeth, PE. She uses this map in an extra B to plan her local trips. Study the map and answer the questions that follow. What type of map does Tandy use in an extra B? Let's go to an extra B. Yeah. This map has a name. We call it a strip map. Others, instead of a map, they write a strip chart. Others can call it a route map. A route map. All right. We said it's called the strip map, or you can call it the strip chart. All right. Some other people call it the route, but this is the right word. So we're going to see, we write that there. So this is called the strip map. Which is the last city that she will pass before she reaches PE when traveling on N2. So this is PE. So that means she's coming from down, coming up. She passes this town, the last town before she reaches. So it's this one here, Human Drop. Name 2 regional roads that she will pass between George and PE when traveling on N2. This is the N2, the middle line here. This is N2. So we are looking for which. So between George, so George is here and P is there. Which regional route will she pass when traveling between, when she's on George and PE? So we have, there's this one here that turns off this side. She passes it before she, okay. Also, they have the 75 here. All right. This one here, it's route 328. They're actually at George. This one here, the straight one. This one here. So this we shall say R33, R330, R75, R330. There was also, but they said 2. So there was also R2, 328, this one here. Okay, it's fine. What is the distance between George and Port Elizabeth? What are we going to do? We shall need to subtract. Or remember, this map, one side, if it starts with 0, so from 0 to here, because George is on this line here. So we shall say it's 321 kilometers. For someone who doesn't know how we get it, you can use now. If you're to use numbers here, we have 458 and 779. So which numbers we are going to subtract this? What's the distance between these two? So we shall say 779 minus 458. Indeed, you will get the answer as 321 kilometers. Can also use that. Okay, we go on. Turn the left George at 5:30 and reach PE at 8:25. 25 minutes past 8. Determine the time in hours taken to reach PE. So we shall say it's duration that we are looking at. Duration. So this will mean the end time or the arrival time minus the departure, the time when someone left, or the end time minus the starting time. So this simply means it will be 8:25 minus 5:30. In this scenario, it's too much. 25 cannot subtract 30. What do? We borrow from the 8, becomes 60. Now this one, 60 plus 25 becomes 85. 85 minus 30, you remain with 55. Remember here you borrowed 1, so you remain with that 7. 7 minus 5, you remain with the 2. So they said they want the time in hours. not minutes, hours. So what you're going to do, it will be, what you're going to do, so what you're going to do, remember we said it's 8:25 minus 5:30. The answer we've got it as 2 hours 55 minutes. They want the answer to be in hours. So this means it's 2 hours already. We change the minutes to hours. We divide by 50. So 2 plus 55 divided by 60. You end up having 2,92. These are hours. They said determine time in hours taken. They didn't say round off. Had they told us round off, it would be 3 hours. Okay, hence determine the average speed at which she traveled in kilometers per hour. Round off your answer to the nearest whole number. Now remember, this is a confusion. They have told you to find speed. Speed, it's this one here. So in your head, you already know that speed equals to distance divided by time. So we already have the distance as 321 divided by now time, which is 2,92. It's the speed, which will become 321 divided by 2,92. So she was traveling at 109,93. Remember, they said round off your answer to the nearest whole number. So this becomes 110. Don't forget the units, kilometers per hour. That's what we are looking at. 2.7. Tandy claims that the shortest route from Worcester to Muscle Bay is the national road instead of the regional roads. Verify using calculations. Now, we are going to look at two distances. We shall compare the distance using the national road, which is the N2. It's going to be the N2. All right. Actually, even this one's N1. National roads. Or we use the regional roads. The national roads, we shall say these are the ones. The distance from here, that's what we are looking at. The distance from here, and we move up to when we reach Muscle Bay here. Or we shall use the distance with routes, which will be this, turn, come here, then the remainder is supposed to be here because that's the other way. So the green route, it's the regional routes. Then the red, it's a national route. Let's continue to say. Now, we continue to say, so I want you to get, we're going to compare distances. So first and foremost, I must start with national, 2.7. When you use the national road, which stations are you going to use? So it's on N1. Start at N1, we start at this place here. The distance from here up to there, it's 46. From here, Pearl, to here, it's 51. Now, the distance from here to Muscle Bay is 394. This is the distance. Now, this is when you've used the national roads, the N1 and N2. What about if you've used the regional roads? That simply means you start from here to there. All right? From here to there. So if you are to use the routes, the regional routes, so meaning we shall start from here to there, then from there to this other part here. There's no there's no route that goes direct to Muscle, because Muscle is on N. It's on the national road. They definitely you have to use the regional routes inside. Then you reach the national road, you complete this other distance that's remaining together. So here, simply meaning, we shall start with 50 plus 29 plus 146. 146, it covers the distance from here and the corner then. Then we add on, 146. This 45, it's from here going up. We shall not go up. 45 is in between there. But we shall not go up that direction. We are just going. So we are continuing this other side. So 146 plus 82. Definitely 82 pushes you to the end. And so what's the distance from here to there? So which we shall say we subtract 394 minus 304, whereby we get 90. So we shall also add here 90. So the national road, if you're to use the national road, we have used 46 plus 51 plus 394. So you end up having 491 kilometers. This is the distance moved on national roads. What about the regional routes? So here we are saying, we said it's 90 plus the 50 plus the 29 plus 146 plus the 82. What answer do we end up having? The answer, we have it as 397 kilometers. So remember, the claim was, Tandy claims that the shortest route from Waterloo is by national road. So we are verifying. You understand? So it's incorrect. It's incorrect. Allow me break it down. We are saying from Watches you go to Pearl, then from Pearl you go to Cape Town, then from Cape Town you go straight to Muscle Bay. But then the distance we found out, there were distance between these two towns, it was 46. That other town, Pearl to Cape Town, 51. And then on N2 we have 394. At the end of it all, we have moved. Remember, this is on the national N1 and N2. Then we verse them with the regional roads, which is these ones here in green. Watches through Robertson, then we go to Matangu, then we turn to, we turn to Riversdale through Leadsmith. All right. So we shall do that. We say what's bed, and then Robert. Then we go to Mtang, and then we go to Mtang, then it goes to Ladysmith, and Riversdale. So the distances we saw in between here, they were from there to there, we have a 50. Then from Robertson to Mtangu, we had 29. Mtangu through Ladysmith, we had the 146. Then plus 82, which is Ladysmith to Riversdale. Then at the end, we add on the 90, which was from Riversdale to Muscle Bay. So we got our answer as 397. 397 97. So if you have the answers 397 kilometers. So these are the regional roads. The regional road. So the claim is what? The claim is invalid. The shortest route is when you use the regional roads. He said, give one advantage of using this map. The advantage of using this map would say it's more detailed, né? Since it's small. So they will try to, and it's straightforward. More, can say it's more detailed. Easy to interpret. Easy to interpret. No? We look at question number 3. That was preparing for a picnic. He cuts a drum into 2 pieces to design a braai stand as shown in the diagram below. He cuts, this is what we call the drum. All right. Then after cutting it into 2, he remains with half of the other, this one here, to make a braai stand. Okay. So the diameter of the drum is 1 meter and the height is 160 centimeters. The top of the braai stand will be, there will be a rectangular grill, which we will put with dimension A and 1.7 meters. The width of the braai stand top is similar to the diameter. And we shall say the braai stand will be half filled with concrete mix. Not mixture, mix. Okay, there we go. So what is the value of A? Remember up here they have told you the value of A, the dimension, we are looking at A, and they say the width of the braai is similar to the diameter. So the width, which is the A, because the length is 1.7. The length is 1.7. What about the width, which is here, which is the A? So we shall say our A will equal to 1 meter. Okay, calculate the area of the top braai stand and round off your answer to the nearest whole number. So they said, first and foremost, they'll give us a formula. You substitute, the length is 1.7 times, the other one, it's what? 1, which becomes 1.7 meters what? Squared. But they said round off to the nearest whole number. So this becomes 2 meters what? Squared. Okay, 3.3. Use calculations to show that the length of the top extends by 0.05 meter on each side. All right. This is a little bit not that hard. It's just logic. Let's look at it and we see what we mean by that. Which color can we use? All right. From here, this is from there, from here to there, it's 160 centimeters. You understand? But the top part of the grill, it's 170 centimeters. I've changed this to centimeters, so you get the answers 170 centimeters. So now, if the braai stand is smaller than that means the grill is longer than the braai stand, which is okay for safety and stability. Because imagine if it was exact 160, it will either the grill will fall inside the fire, or actually it would fall inside the fire. It will not have that standing part of it. Okay, so now here we go. we shall say 170 minus 160. What's the answer? We remain with the 10. These are 10 centimeters. So we need to divide it equally on both sides. So simply meaning we divide by 2. The answer becomes 5 centimeters. We don't want centimeters, we want meters. So we divide by 100. So the answer became 0.5 meters. So you've proved it. We are doing question number 30.3. I was trying to explain it in a logical way. Right? That is it. Another way how you would have done it, it's that still we change the 160. You say 160 divided by 100 comes 1.6 meters. 1.6 what? Meters. Then we subtract 1.7, which is the braille stand, which is exceeding the length of the braille stand, which is the length of the grid, minus the length of, which gives you 0.1. These are already meters. So what do? We divide by 2. And the answer becomes 0.5 meters. Same story. Hence, calculate the capacity of the drum. Now, capacity of the drum, I've told you capacity equals to pi r squared h. Don't forget, do you have, because the formula says find the capacity, and it says pi r squared h. So do you have pi? Yes, 3.142 times. Do you have the radius? No, we only have the diameter. So the diameter will become radius. Radius will be diameter divided by 2. The diameter, it was 1. So we have 0.5. Come and substitute it here. Times the height. The height, we've already changed the 160 centimeters, change them to meters. You have 1.6. So you come here, put 1.6. So 3.142 and 0.26 squared times 1.6. This is meters what? Don't forget, it's in meters cubed. Meters cubed. Someone else would have changed it to liters, which simply means you would have calculated it in a in centimeters to make a clear picture. Now here we go. Determine the volume of the braille stand that will be half filled with concrete mix. So the volume equals to, same story, pi r squared h. However, now it's a half. So the volume will be by the way, you can, let me see here, they said, no, here they say the capacity of the drum. That's a full one. Then here, the braille stand. Now remember, the braille stand comes from the drum and it's already half. So it will still be the same, which is 3.142. We multiply. I will do my, all my numbers will be in centimeters. So this is 50 centimeters squared times the 160. times 160, 30,142 times 50 squared times 160. So the volume we have it as this centimeters, what? Okay, but because it's a half, we need to divide by 2. Divide by 2 and becomes centimeters cubed. If it's needed in meters, centimeters to meters, we divide by 100 cubed. Divide by 100 cubed. Which will be 0.6284 meters, right? Cubed. Okay, now we go to question number 3.6. Remember up there, we've already got the answer as the this was our volume in the meters. Meters cubed. So here we go. Here we go. The concrete mixture, the concrete mix is sold strictly in wheelbarrows at a local hardware store. Take note of the following. 1 meter cubed, it will take, or it will need 20 wheelbarrows. Then the cost of 1 meter cubed of concrete mix is 1,800. 1,800. Use calculations to determine whether the cost of the concrete mix needed have to pay the price stand will be less or more than 300. All right. So now this is the volume. All right. The volume of the half the tank. Half the tank. But then the concrete is also going to take a half again. So meaning we need to half this volume again. We divide again by 2. So we divide this by 2. So this will be the volume to be filled with the concrete. Volume to be filled with the concrete. So it's cubed. So we find out how many wheelbarrows do we need for this. So this, actually, we just need to multiply by the money because we are proving the money. Because these are the, it says 1 meter cubed, one pays. So what about for 0.3142 meters cubed? So the person is going to pay 500. So the money is more than, it's more than 300. Look at question number 4. Look at question number 4. Tepo is planning to travel from Centurion to visit his family in Soweto. He studies as a map as he is a new driver. Study the map and next just see and answer the following questions. Question 1. Name the type of scale that is used on the map. Let's go to the annexure. Now, when you look at it, this is the map. Let's just see. So they're asking which type of scale is it? There's this scale here. this one we call it a Pascal. So the type of scale that we have here is, say, it's a Pascal. Name the neighboring provinces found on the eastern and the western sides of Gauteng. So we know very well this is the north. This is north, and then this is east. This is west. So neighboring provinces, here we have Mpumalanga, and here we have northwest. So you can say eastern. Eastern, it's it is Mpumalanga. Mpumalanga, and western, in the west, it's the northwest. Use the given scale to calculate the actual distance between Centurion and Soweto. Actual distance between the actual distance between. So the actual distance now simply meaning you need to measure the distance. First, you're going to measure the distance between Centurion and Soweto. You use the ruler on the side of millimeters. Measure the distance between we shall measure the distance between it's approximately 52 millimeters. All right, approximately 52 millimeters. Then, since we are measuring, now this is not the actual, this is a measurement on paper. So after that, we come down here and we also measure the sector of we shall measure from here to there. Only this. So this is approximately 10. So you've measured the scale. So now, what scale are you going to use? It simply means if you have 10 millimeters, you have an equivalence of 15 kilometers. However, I got the kilometers, they are telling me that they allow me use the map because they don't have space. So the scale so the scale it's 10 millimeters are equivalent to 15 kilometers. But for you, you've measured the distance between Centurion and Soweto, it's 52 millimeters. What will it be in real life? So what do we do? Cross multiply. We don't know this distance. So it will be 10 h equals to 15 times 52. Because you're looking for h, you divide through by 10, divide through by 10. And the answer becomes 780. You divide by 10, the answer becomes 7. . That's how it's supposed to be done. The reason why I didn't convert this story in kilometers, and in actual sense, the distance has to be kilometers. So that's done. Let's continue. Let's continue. Okay. Still on the map. Here now we found out that we have 78. What? We have 78 kilometers. Hence, simple meaning, basing on 4.1.3, use this to determine this. Now they say, hence determine the number of liters of petrol required to cover a return trip if consumption rate of Tsepo's car is 0.086 liter per kilometer. You see that? Now, what I would like you to understand here is that they have talked of a return trip, simply meaning going and coming back. So you're going to get the distance, multiply it by 2. The distance, multiply it by 2. So what is the distance covered there? It's 156 kilometers. Now, for only 1 kilometer, you spend this much liters. What about if you have 156? So we shall need to multiply by 0.086. Should need 13.42 liters of petrol. 4 liters of petrol. What is the probability of finding a toll gate in the southeastern side of Johannesburg? Express your answers as a percentage. Let's go and we see. First and foremost, you have to identify the southeast of Johannesburg. This is Johannesburg here. So southeast is this side. How many do we expect to see? We have 1, 2. So the probability will be 2 out of how many are they? We have 1, 2, 3, 4, 5, 6. There are 6 toll gates all in all. 6 toll gates all in all. So divide by 6. But they want it as a percentage, multiply by 100. So it's 2 divided by 6 times 100, which is 33.33. Don't forget the percentage. We repeat, probability as a percentage. We said there are only 2 toll gates in the southeastern part of Johannesburg. Then, but how many toll gates are they all in total? There are 6. But they want the answer to be as a percentage. We multiply by 100. And the answer, we've just got it as 33.33%. Okay. Taipo decided to pave the swimming pool area of his family home in Soweto. The shape of the swimming pool is a square with each side 9.84252 feet. And they have told you one foot is equivalent to 0.3048 meters. And the area of the backyard where the swimming pool is situated is 7 meters by 5 meters. So it's a rectangle. So there we go. Convert the side of the swimming pool to meters. So they've told you, if I have 1 foot, I have 0.3048. But these are what? Meters. But now I have more than 1 foot. Definitely, it's going to enlarge. So it's going to be 9.84252 2 feet, we need it to become meters. I'll call it letter B. So I cross multiply. So my B now will be, my answer here has to be 9,84252 times. We are supposed to multiply. The reason why I have a B here is because 1 times B, you get B. That's straightforward. So 9,84252 times 0, not 2 over, not over 4, like water spilling, you know. Then yeah, even when someone dives in, they should not, the water should not overflow. The water should not flow out of the swimming pool, not overfilled. You understand? And the principle of physics says the body mass, a body mass in a fluid displaces an equal volume of water. Explain the difference between capacity and volume. Now, what I want you to know, capacity is how much can be, this is what? Contained. How much can be contained in a given object or given container. Then volume is the space available. The space available. Now here, in this context, we shall say capacity, it was the word, how much water can the swimming pool take? You get that? Then volume would be how much space is in the, how much space does the swimming pool take? When it has no water, how much space is it? You understand? Okay. Determine in meters squared the area of the backyard that will not be paved. Take note, that will not be paved. Let's go back to the diagram. Now, area that will not be paved. The area that will not be paved. Remember they said Zepo wants to pave. Zepo said to pave the swimming pool area of the family house in Soweto. The swimming pool area, that says. So there's a certain part that will be, but this, the area that will not be. So here it's simply meaning we are going to subtract. So we shall say the area of the yard, which is the backyard, which is 7 times 5. You get 35 meters squared. And the area of the pool, which is already 3 times 3, becomes 9 meters squared. Subtract the 2, 35 minus 9, you end up having your answers 26 meters squared. Question number 5. Tipo lives in Pretoria and travels daily to work in Rosebank using how train? Is his reporting time In other words, the starting time. The login time is supposed to be 8. He has to be at work at 8 every day. He walks for 10 minutes to his workplace from the Rosebank. Definitely Rosebank. The place that he works in is the Rosebank, but walking from where? The Rosebank, what? The Gauteng station, working from there too. Then study the Gauteng timetable study the Gautrain timetable in the next year and answer the following questions. So what we're going to do is 5.1.1. Which train, southbound or northbound, must he take in the morning to work? Explain your answer. Let's go there and check their mixture. Now, remember, he lives in Pretoria. He lives in Pretoria. He works in Rosebank. So, what are we going to do? When we look at this one here, it's departing from Park Station to go to Rosebank. It goes to Sandton, Marlborough. Then afterwards, it's in Pretoria. And it's in what? Hatfield. That means this one is coming from Park Station. Remember, for him, he stays in Pretoria. So definitely, yes, because this one's departing from Pretoria, heading to Rosebank. You see that? So the train that is going to use, it's southbound. Because it runs from Pretoria. Southbound because it runs from Pretoria. Southbound because it's from Pretoria. What is the latest that he should depart from Pretoria if he wants to be at work on time? Remember, he has to be at work at exactly 8. Definitely cannot get a train that will drop him at exactly 8 because he has to walk 10 minutes. That means he will reach 10 past 8. So for him to catch a train, the train that he should take, he should arrive at Rosebank before 8. Let's go and see. Now here the trick is we've chosen the train as this much. So it's from Pretoria to Rosebank. So we shall come to Rosebank and we look for the train that has, because this one it's no, because it's already past 8. This one never. So it's supposed to be the train. So this train here is this one here, that because now this one it will arrive at Rosebank at what? At 7:49. So it still has 11 minutes to 8. You see that? But remember, he has to walk 10 minutes. So 11. So he has 1 minute to spare. Yes, sir. So they are saying the latest. So which to depart from Pretoria. So we shall go and see that train. When does it depart from Pretoria? It should depart at 7:18. So you should leave Pretoria at 7:18. This is when he's panicking. Here you'll be rushing because he has to beat the time. Calculate the duration of Sipo's journey to work, including the walking time. what shall do is that the duration now it will be, we say 7:49. That's when you arrive at the bus station. Then minus, we want to know how much time has he spent on the train. So there we go. He has spent around 49 minus 18. He has spent 31 minutes. You see that? 31 minutes. Then on top of the 31 minutes, we add on the walking time, which will be 41 minutes. Give two advantages of how train. One, it's safer and it's fast. It's safer than our metro trains. Okay, the average temperature in Pretoria is 30 degrees Celsius. Convert this temperature to Fahrenheit. All you do, where you see the C, you put the 30, substituting the formula. So it's supposed to be 1,8 times 30 plus 32. So we get the answer as 86 degrees Fahrenheit. 86 degrees Fahrenheit. $80 degrees Fahrenheit. So I, can after can, MN, JF. F during T breaks. He used a tree diagram to explore the possible options of snacks. Study the tree diagram in the next year E and complete it by writing the correct letters next to Roman numeral 1 to Roman numeral 3. Okay, let's go and we see their next year there. Here we go. Yeah, this is what we call the tree diagram. These are the possible outcomes. So I, remember we are giving answers for I. This one here, what could be the answer? Now, this is N, and indeed there's N here. That means this M came from here. So our I, it's M. We go. So Roman numeral 2. Roman numeral 2, we have JN. We already have J. That means this is what? N. Roman numeral 3, which is, we are going to take J and F. So this is JF. So it was MNJF. MNJF. All right. Sipper bought canned fruits and he must pack the cans in a plastic container. The dimensions of a can and the container are shown below. All right. The can is a cylindrical, it has diameter and height, and the container there it's rectangular. So this takes us back to packaging. Tumela advises people to pack the cans upright so that he can pack 1,134 cans in the container. Verify his claim. So first and foremost, you're going to look for how many will fit on the long side. If they are, because if it's to be packed upright, it's going to be one can, the other can, then also we go on top, can after can. You understand? So we want to know how many cans will they be. How many cans do we need here? You know, this is this is what it means, being packed upright. The cans are going to face up like that. But we need to know how many will they be. Okay, so what we're going to do, we shall say number of cans on one, we shall say on the long side, which is the lengthwise, on the long side. So if we want to find out how many will they be here, so we shall take the length of the box, the container, divided by the diameter of the can, which will be 126 centimeters, divided by the diameter, which is what? 6. So this is approximately 21. Those are 21 cans. So on the long side, we shall have 21 cans. 21 cans. So what about on the short side, which is widthwise? On the short side, we shall have the width of the box or the container, this one here, the rectangular, divided still by the diameter of the can. So let's go and we see. The width of the container is 53. So 53 divided by 6. 53 divided by 6. We have 8,83. And continue. Now, this simply means even though it's 8, when we round, because these are cans, you can't have half a can. You understand? So you're supposed to have a whole number or a big number, a number. So this simply means, yes, 8 feet exactly. But should you try to force in the 9th one, it won't fit. So we have 8 cans on the short side. So what about the layer wise? Because the only one layer has, the first layer has 21 times 8, which is approximately 168. 168. So what about if you have to pack them on each other? How many cans will they be? So we are looking at number 3. How many layers are we going to have? Layers, we shall see. We shall take the height of the box divided by the height of the can. So the height of the box, let's remind ourselves, it's 72 and the height is 12. The height of the can is 12. So 72 divided by 12. 72 divided by 12. We have the answer as 6. So these will be layers, not cans. Each layer will be holding 160. So all in all, how many cans do we have? 168 times 6. We have 1008 cans. So the claim is what? It's invalid. The claim is invalid. This marks the end of our question paper. This marks the end of our question paper. Thank you very much. Bye-bye. Let's look at question number 3. Question number 3 looks at area, perimeter. As we go on, we shall be looking at area, perimeter, among others. All right. We'll go straight to question number 3. The picture below shows the dimensions of the rectangular vegetable garden with 2 gates. The garden has a length of 35 feet and 17 feet respectively. It has a length of and a width. It has a length and a width of 35 feet and 17 feet respectively. Simply meaning the length is 35 feet and the width is 17 feet. In that order, respectively means in that order. All right. Note the width of the small gate. Okay, when you look at the garden, this is it. Those dots are poles that are going. This line they represent the round one represents a fence. Then these are the gates where one will enter from, and indeed this is a pathway where one goes through, and you go out from this other side. Okay. The width of the small gate is 9 meters, and while the width of the large gate is 18 meters. The garden will be fenced with a galvanized welded meshed wire. Study the diagram and the information above and answer the questions that follow. Question number 1, 30.1.1. Explain the term perimeter according to the given context. Now we shall say, remember, perimeter is the total distance around the given shape. Now we shall say the total distance covering sorry, not covering, total distance around the vegetable garden. Total distance around the vegetable garden. The total distance, you can say length around the vegetable garden. Vegetable garden. State whether the dimensions of the garden are in metric or imperial. Remember, metric is where we look at kilometers, meter, centimeter, millimeter. Now, imperial, we look at miles. Imperial, we look at miles. We have yards. We have feet. We have inches. So we go and we check on the garden, the dimensions. They are in feet. So your answer is what? The measurements here are imperial. Measurements there are imperial. Another thing that I've forgotten about the perimeter. Perimeter, it's when you start from here, you come there, you come there, you come here, again you go. So the distance that you move from here You go like that, you add. That's how we get the perimeter. When you move around a given shape of a given area, around, which means outside. Meaning it's the same as the space occupied by the fence or boundary. All right, a boundary around a given shape or area. Determine the ratio of the width of the smaller gate to the large gate. Remember, they gave us those measurements. They're here. But what I wanted you to know, first and foremost, know its ratio of the smaller gate and the larger gate. So smaller gate, what's the width? We come back to the scenario here. We have it at 0.9 meters, and the large gate is what? 1.8. In that order, please. 0.9 is to 1.8. Simplify it, become 1:2. 1:2. Calculate the perimeter of the rectangular vegetable garden in feet. You may use the formula below. Now, someone might ask us, shall we count the gate? Yes. Why? We are looking at the vegetable. We are not looking at the fencing, but we are looking at the perimeter of the garden. They are saying it's supposed to be in feet. Remember, length is 35 feet. And the width is the 17 feet. Substitute. So we shall say perimeter equals to 2 into 35 plus 17. We are looking at perimeter. Perimeter needs us to have length. It's already given to us at 35. These are feet. Then we also need to have the width, which is 17 feet. So we need to substitute, and we shall say perimeter equals to 2 into length plus width. I'm using this other part here, which is 2 into 35 plus 17. See that? So we go straight forward, and you see you have the answer as 104. These are feet. So they are telling us, hence convert the perimeter of the garden to meters. So here we already have it as they are telling, if you only have 1 foot, you have an equivalence of 0.3048 meters. So for us, we have 104 feet. What would it be? We cross multiply. So the answer is to be 3. Telling us it has to be 3,16992. These are meters. In other words, it's the same as 3,31,70. All right. The roll of the mesh wire in the base roll in the meshed garden is sold in rolls of 120 millimeters. That's how long it is. But then the wire covers 10 meters. So 120 meters high and the length of 10 meters. So they ask you, determine the number of rolls of wire required to fence the rectangular. So before we do this, remember now this is when we are going to exclude, or this is when we are going to look at the gates. Why? Now you're bringing in the fence. Definitely you want to cover the face the gates. So what we're going to do, total perimeter of the fence. So we already got the answer there up there, which way we said it was 35. Added the 17. We got the answer as what? These were feet. We changed them to meters. And the answer we got it as what? 31,6992. Here, we shall subtract the length, the width of the small gate, which is 0,9. And we shall subtract this width of the smaller gate, which is that much. So remain with 28,9992. So these are the meters that we need. So we shall divide this by 10 because it's sold in 10 meters. So we divide that by 10. You see, you find yourself that you remain with 8,9992. But remember, these are rolls, so you cannot buy them in half. So the person will buy 3 10-meter rolls. 3 of them, but the third one won't be fully used, but part of it will be used. They're asking you can get the total cost of the machine wire face. That's so already we've seen that we need 3. 3 times 1,599. The answer that you get, equal to that much. Answer you get to equal to that much. Give one valid reason for putting a fence around the vegetable. And then the valid reason is known for the animals known to destroy the garden. You know, if you have animals at home, you protect them. You protect the vegetable garden from those animals. So by putting what? A fence, not to destroy the garden, the livestock, not to destroy the garden. Then the other one, what would it be? Also to be neat, protect your garden from intruders. Three 3.2, when you look at 3.2, almost the same part that we're looking at. And here we have this diagram, yeah? Now this is from Mr. Malin intends to increase the area of his garden to plant more vegetables. The diagram below shows the dimensions of the existing garden and the alternations to the new garden. You understand? The existing is this blue one. Then these dotted ones are the extensions, which becomes the new garden. The garden has a circular garden bed with a diameter of 1,5 meters. Okay. Determine Mr. Malin's new length of the garden. Now, you're taking the old plus the new one. So it's 11 plus 2. So the new length equals to the old plus the new. So we added that up. Take the area of the new garden in square meters. So the width is 6 meters and the new garden is 13. So let's go there and say our length is 13, the width is 6. And the answer becomes 78. The answer becomes 78. Don't forget these are meters what? Squared. You show the units because even there they said in meters squared. So please, you don't forget the units. These are just meters, they're not squared because just we are adding. Here it's a square because we've multiplied 2 times. We've multiplied the meter from here and another meter here. So we multiply the 2, you get meter squared. Here we're just adding. You don't get anything. It remains the way it is. We go to 3.2.3. Martin stated that the percentage increase in the area of the new garden is 40%. So how are we going to get this? Number one, we shall need, we need to know, because to get the percentage change, you need to get the new area. Allow me write it like this. Minus the old area. Everything divided by the old area times 100. Why? I'm looking for the percentage. Anyway, I have the new area. What about the old one? So I need to look for the old area, which will become L times what? B. Let's go back to the diagram. What's my old area? It's 11 by 5. So I'll come here, multiply 11 as length, 5 as width. And the answer becomes 55 meters what? Squared. So I have the old area. I'm good to go. I'm going to substitute. I'll say my new minus old divided by old times what? 100. The new is 78 minus 55, which is the old. I divide by 55 and multiply by 100. What answer do I end up having? 70 minus 23 divided by 55 times 100. So the answer here, you have it as 41.82%. So if you round it to, it's what they are saying is that the percentage increase. No, the answer is what? Invalid. Why? This is not 40%. And he said it's 40, and it's above 45, it's 40%, then it will be valid. Why it's above? And this said it's less, it will be false. Incorrect. All right, let's look at question number 3.2.4. Show by calculations that the area of the circular garden bed is 1,767375 meters what? Squared. Remember, we are looking at the circular garden. And indeed, they have given us the circle here. They have given us the area. The area needs the radius. And in the scenario, remember, they told us that it has the diameter. So how to get the radius? Radius equals to diameter divided by 2. They told us the diameter was 1,2. The answer becomes 0. You see, the diameter is 1,5. Sorry, not 2. So we do that. 1, divided by 2. We have the answer 0,7. Now our radius is 0,7. So we come substitute in the formula. Squared. So 3,142 times 0,52 squared equals to 1,767375. 75. 76, 73, 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 75. 3 marks.